Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how the basement roof level is given. Okay. So far, we have understood about the plinth beam, right? So once the plinth beam is done, the next drawing that we are supposed to look is about the basement slab. So I'll take you to the basement slab now. So you can see it here. Revised basement roof slab layout. Okay. So the revision point we have understood. Sometimes there will be a revision, and that is how it is written revised. If there was no revision, then directly they would have written basement roof slab layout. Since there is a revision, he has written it here, revised basement slab. Okay. Yeah. So now why is that? Why we are looking at the basement? Because this, like I mentioned, this structure is a basement plus a ground floor plus a 3-story building. So that is why we are saying the basement here. Okay. Yeah. Now again, what do we understand from the structural drawing? This is going to give us the shuttering layout and all. Like what is the shuttering? What is your, what should be the thickness of your slab? What should be the width of your beam? All those things you're going to get from this particular drawing. So always remember, sometimes people write this as revised, sometimes people write this as basement roof slab layout, or even this drawing can be called as a shuttering layout. Okay, shuttering layout, because it is going to help you in putting up the beam bottom and the slab centering and all. So that is why few people indicate this by shuttering layout, and few people don't write shuttering layout directly. They say basement roof slab layout. Both are one and the same. Yeah. So we'll start to understand this again. You can see here how the columns have been marked, isn't it? Because columns, once it starts from the foundation, it keeps on going. I mean, it will continue. You're not going to, discontinue that. Again, quickly we'll see that. See the red color one, what you can indicate, they all are of the same size. And here you can see the purple color one, they all are of same size. And in this part, we have a green color. Again, this green color is of a different size. Okay. Here they have not mentioned what exactly is the size, but when I come to the ground floor part, no, I'll explain it, because you can see it here. This is a ground floor roof slab layout. Here he has given that, okay, how many C1 columns are there, how many C2 and how many C3. Of course, in the footing layout also we have seen that. But here specifically, here itself, this particular engineer consultant has given it here. But whereas in the slab, in the basement roof, he has not shown, but it is okay for us, okay. And now you can see here, he has given a floating column, right? You can see floating column. The size of the column is 9 inch by 9 inch, and here you have to make use of a 12 diameter 4 number of bar. And what is this floating column? Because this particular column is coming from the which portion? This particular column is going to come from the basement roof level. Okay, you don't have a foundation. Okay, this is coming from the basement roof level. That means at the time of casting of this slab, you have to leave the double bars here so that you can take a column from here. Okay, that is why it's written floating. You don't have any foundation. Whereas all the other columns, what you can see, all this column started from the foundation level. Whereas this column is not started from the foundation level. Yeah, you don't have any foundation, but the rebars are inserted into this particular beam so that it can transfer the load to this. Okay, yeah. Now again, what we can try to understand is that, obviously, all those things will be given here. See here, here we have a slab. The name of the slab is S1. What is the thickness of the slab? It is a 4.5 inch thick. Similarly, I have a slab here. The name is given S2, and it is a 5 inch thick. Now again, what will happen? The structure consultant will differentiate, okay, whether it is a one-way slab or a two-way slab. If it is a one-way slab, he has given a name as S1. We can see here only one direction is showing. That means your load is going to transfer on this beam and also on this beam. So this is your one-way load distribution. He has given one way by the name S1, and wherever we have two-way, like for example, if I take this particular slab panel, you can see both the direction is showing. He is showing in this direction, and also is showing in this direction. That means your load is going to come on this beam, on this beam, on this beam, and also on this beam. Again, quickly, I don't know how many times I've told it, but still, if someone who has already listened to it, it's well and good. If not, quickly I'll tell you how the distribution will happen. Okay, sometimes what happens is I need to explain them. That is why I tell. That is the reason I tell. Maybe I repeat sometime, but that's okay. If you have understood it, well and good. If not, no issues. Just listen to this once again. Is this okay? No. Wait. This will not happen. It has to go in this way. Okay. Yeah. Yeah. So this is how the load distribution will happen. Okay. What will happen when the load comes? Whatever slab load comes in this trapezoidal portion, this much portion, it will be transferred to this particular beam. Whatever triangular load is going to come on this portion, it is going to be transferred on this particular beam. Whatever again trapezoidal load is going to come on this slab, it is going to be transferred on B15 beam. And whatever triangular load comes, it will be transferred on this B95 beam. So that is how the load distribution happens. So this is a two-way distribution. Now, if you ask me how the load transfer happens in a one-way slab, in one-way slab, the majority of, I can say again, the reason is that in one-way slab also, the load will go on all the four beam. Practically, one-way slab is not possible, right? So load will go on this beam, this beam, this beam, and this beam. But what will happen? The amount of load which goes on this and this beam is very less. So we say that much of the load won't go. It has been seen that 95% of the load will go to this particular two beams. Okay, I'll write it here 95%, and only the 5% of the load will go to the other two beams. That means if I write it in this way, that means let me denote it in this way. Yeah, so this is a major beam. Okay, this and this. Here on these two beams, 95% of the entire slab load goes, whereas on this beam, okay, on this beam and on this beam, only 5% of the load goes. So we neglect that portion and we say the load will get transferred in only one direction, that is on this direction. That means here and here the load is going to go. But practical load will go here also, but the extent of load is very less. So we neglect that and we say this as a one-way slab. Got it? Yeah. So again, here S1, it is understood. Got a concept? So with this understanding, you can look into any of the structural drawing and you get an idea. Suppose if I ask you, like explain me about this drawing, it's understood that here we are using a 5-inch thick slab. Okay. And these are the beam number which is surrounding this particular slab. Okay. So in this way, they have given it. You can see wherever you want. That is how it has been given. Okay. Yeah. Yeah. Okay. Along with that, what we need to understand is about the beam. Again, here the beam numbering is given. Like this particular beam is B43 and the size is 12 inch by 18 inch. It is B91, B49 and B100. So here only the size is given. That is a breadth and the depth. 9 inches is a breadth, 18 is a depth. We don't know the steel details and all. For that, what we are supposed to do, we are going to look into one more drawing. Okay. So that drawing is about the schedule of RCC beams, and that is for the revised basement roof beam schedule, right? So here, whatever beam number you can see it here, right? Like B44, B45, B50, 51. For all those beam, they are given a numbering here. And for this, you are going to get the size. Obviously, the size you can see it here also. But when it comes to the cross-sectional details, like what is the steel and all, for that we have to refer this particular drawings. Got it? So again, all the things will be given here. So as an engineer, we should be in the position to identify which is a beam number we are looking for and how to understand this steel. Of course, how to understand this steel we have already seen. We know how to understand because I have taken a normal commercial building. The first lecture I have explained you through a video, so it's a more clear. The same pattern you can see it here, but still I can explain you for one beam so that we don't have any confusion left. So I'll quickly take one of the beam from here. Okay. Other than that, rest all things are very simple. We have a lift coming here. So it's an X mark. That means you're not going to put any slab here. You have a duct portion here to take your sanitary pipes and all. Again, there's an opening here. So this is a staircase portion what you have. And this is the double bar because they have a plan of taking a staircase here. So that is why at the time of casting of this particular beam, you're going to leave the double bars. We have seen what is a double bar, which is a 12 diameter at 6 inches center to center spacing. Got it? Yeah. So I think most of the things we have covered. So coming to this beam part, we'll quickly try to understand the beam part also. So let me go with this particular beam for our understanding. I'll go with this particular beam. Okay. Yeah. Yeah. So again, what is the size? Size is 9 inch by 21 inch. What is the beam name? So all B1, B4, B22, B64, 67, or whatever numbering beams we have to follow this particular steel for that. Now coming to the bottom steel, straight portion, you have to provide a 16 diameter 2 bar, right? If I try to put a cross section, something like this, okay, let me do it in this way. If this is my beam, I'll go with the bottom bar. Let me go with the bottom bar. Yeah. So this is my bottom bar. So how much it is? It's a 16 diameter 2 bar. So I'm doing a longitudinal view. So I can write it here. Okay, I'll write it here. It's a 16 diameter 2 bar. 16 diameter 2 bar, right? Yeah. Now coming to the curtailment bar, we don't have any curtailment bar. It's a dash, so we don't have any curtailment bar, right? So if there is a curtailment bar, let us consider if there is a curtailment bar, what would have happened? Let us say here they have mentioned a 12 diameter 3 bar, right? If it is a curtailment bar, what would have happened? Very simple. You would have provided a bar something like this, and you would have stopped somewhere here. This is your curtailment bar. Got it? And what is the length of the curtailment? It is given 0.7 into L1. Whatever is the length of your beam, multiply that by 0.7. Whatever answer you get, no, that will be your this entire length, and this much, and on the left this much side, and on the right this much portion you're supposed to leave it. And we know what is the reason behind all these things. Since we are looking into the advanced course, considering the bending moment effect, we have understood that. Yeah. Now we'll go back. Yeah. Then now coming to the top steel. In top steel, in the mid span, you have to provide a 16 diameter 5 bar, and then you don't have any extra steel, right? That means what we're supposed to do, we are going to give a 16 diameter 5 bar. Of course, in the drawing, we are going to see only one bar. Again, I'll go with the 16 diameter. Okay, this is my 16 diameter. How many bars? It is a 5 number of bar. I'll write it in this way. I'll write it. So it's a 16 diameter 5 number of bar. Got it? In a single layer itself, we are going to provide. If you want to understand the cross section of this, quickly let me draw a cross section for that. So we'll go with this cross section. I'll do it here. Yeah, if I do a cross section, so in the bottom, what we had in the bottom, we are supposed to provide a 16 diameter 2 bar. So one bar will be here. This is my second bar. Okay, and in the top, I'm supposed to put a 16 diameter 5 bar. So for the 16 diameter, again, I'll take a different color for a better understanding. So one bar is here. Okay, this is my second bar, third bar, fourth bar, and a fifth bar. Great. Yeah. Now coming to the stirrup part, it's mentioned here. You have to provide a 8 dia bar at 6 inches center to center spacing. Even rest is also 8 dia bar at 6 inches center to center spacing. That means this is 1/3 of the span that is near the support. If I want to draw one line, this is the last time I'll explain you. Okay. After that, we'll not try to understand this in a more detailed way, since we already seen it many times. Okay. I'll take this is my support on the left support, and this is my right support, and whatever is left out, no, that is my center portion. So now you can get an idea. Support at 1/3 of the span. So this is 1/3 of the span, and this is also 1/3 of the span. Here I'm supposed to provide a 8 diameter bar at 6 inches center to center spacing. So quickly, if you want, I can do it for you. So quickly, let me put that. So this is my, yeah, this is my 8 mm bar. Okay, at how much? 6 inches center to center spacing. 6 inches. Similarly, here also 8 diameter bar at 6 inches center to center spacing. Okay, great. And what about the center portion? Center portion, that is a rest. Rest in the sense, this is rest, isn't it? The center portion is a rest because already the left and the right support is covered. So it's mentioned 8 diameter bar at 6 inches. So in the middle portion also you have to provide the same thing. But usually the trend, like I mentioned, sometimes, not all the time, what will happen in the center, you're going to increase the spacing, but it all depends on the shear force which comes. Okay, sometimes in the beam, what happens, the shear force will be maximum near the support. In the center, the shear force will be less. Sometimes throughout the span, you're going to get the same shear force. Okay, in that case, we'll not decrease the spacing in the center. We'll try to keep it same everywhere. You can see here, everywhere near the support also it is 6 inches, and at the center also it is 6 inches. That is okay, and we are, I mean, that is how the designing is done, and we are okay with that. Again, it all depends. Okay, if the length of your beam is very long, in that case, we don't try to go with this increasing the spacing in the center. We give the same. But again, like I mentioned, it all depends on how the design values we have got, either from the STAAD Pro or maybe from the ETABS. Based on that, we have to do the designing. But if you observe it here, yeah, I can take this as an example. See here, what has happened here in this particular area, like for B18, 20, 28, you can see they have provided an 8 diameter bar at 6 inches center to center spacing at the support. That is here and here. You have to provide an 8 diameter bar at 6 inches. But when you come to the center, no, it's an 8 diameter bar itself, but the center to center spacing is 8 inches, right? So that means center you are supposed to give 8 inches center to center spacing. It all depends how the design has been done, or what is the load coming on that, how the load travel happens and all. Anyhow, so I hope up to here your concepts are clear. You have got an idea. Of course, you can just try to understand how this structural drawing is made up. I've explained you for one of the beam, and even at the time of the plinth beam also we have understood with the help of site videos and some site photos and all. So that is why we'll not try to get into the more detailed here. But if you have any doubt, you can always ask in the comment, and you can put a screenshot just in case if you're not able to understand any of this here. So I'll just scroll it here in this way. If you are interested, you can take a screenshot out of this, and then any doubt you can always get back to me. Okay, so this is how I've done it. You can take a screenshot of this. Try to visualize this rather than taking a. Of course, you take a screenshot at the same time. Just visualize what exactly is happening. Okay, just look at the number and try to visualize how this. For example, let us consider B8, 16, 27, 59. Try to visualize how this beam will be done practically in the site. Okay, it's a 12 inch by 8 inch. Good. So bottom I have to provide a 16 diameter 3 bar. So this 16 diameter 3 bar has to come. I mean, you have to imagine this 16 diameter 3 bar in front of you. Okay, good. Curtailment also we are going to provide a 12 diameter 3 bar. Good. That means in the bottom I'll put 16 diameter 3 bar. I'm going to give a spacer bar, and over that I'm going to keep a 12 diameter 3 bar. It's a curtailment bar which will not go completely. Okay, that is great. Now coming to the top portion. Top portion in the mid span, I'm supposed to provide a 12 diameter 3 bar. Oh, good. So throughout the span, a 12 diameter 3 bar will go in the top, and extra steel at the continuous support, I'm not supposed to provide anything. And wherever I have an end support, I'll give an extra bar, that is a top right extra or whatever it may be, a 16 diameter 3 bar extra over there. Got it? We'll try to see how the slab reinforcement has to be given. So far we understood about the beam reinforcement, right? So how to understand the slab reinforcement? For that, you can see it here. This is a slab layout what we have. But one thing, if you had carefully observed, you can see a lot of section has been drawn here. You see it here. What is written here? I, right? This entire green dotted line, what you can see, it's the entire section what they have cut. That is I section. Okay. Now in the same way, if I show you one more section, just concentrate here. You can see it here. Another one section has been cut here. So this is E section up to here. This is my E section. In the same way, if I go to the G section, you can see, if I try to zoom in, you see here, it's G section. It has been cut from here, and I think it has gone all the way, cutting all the slabs. So because different consultant use different ways of giving a steel, so that is why we have to follow this in this particular building. So it is given G here. So you can see it in this way. They've started from A and they've gone up to like G, H, K also we can see it here, right? Let me try to see where exactly the A is given. So maybe, we can see the B here. See the B cross section is here. You can see. This is B cross section here, B. And similarly, we have a cross section here. Okay. You can see the A cross section here in this part. So this is A here. It has gone up to here. So what exactly conclusion we are going to draw from here? So that means if I want to put a slab reinforcement in this particular area, I'll look into this AA section. Okay, that means we get another drawing for this. That is a cross section. You can see it here. Yeah, we have to go for the basement revised one. Yeah, you can see here basement revised roof slab section, and you can see whatever section we had seen, the same section they have mentioned it here. Like you see section AA, then we have a section E. Yeah, this is section EE. Then we have section BB, C, D, F, G, H. So in this way, all the sections has been given. So this is a bit complicated when compared to the other drawings. If I had taken my earlier. If you had taken my earlier drawing reading course, there we had very simple slabs and we were able to understand that in a more better way. Since here the consultant has given in terms of section, now it becomes a bit challenging for us to understand. But anyhow, always a good thing if you understand. Now first we'll try to concentrate from here. Section AA is given. Good. So let me bring that drawing here also. I'll take this out. Yeah, basement roof slab section. It's not required. Yeah, this is the one we were looking, right? Yeah, revised one. So I'll bring it here. and we can go together. Yeah. Yeah. So we'll go with the A section now. Okay. So if I go for the A section, just concentrate here. One, if you understand, it's always easy for us. A has been cut here. See through which beam it is cutting. It is cutting B75 beam, right? Again, it is cutting this particular beam. Cutting in the sense, see, I have a beam running here, and this green dotted line is going through that, right? So just mention if you are, if you have time or if you have a pen and paper, you can note it down so that we can verify. Cutting B86, it is cutting B95, B104, then it is cutting even this beam, right? B113, and it has been stopped up to here. Now, when I go for the cross section part, so remember this B75 and B86, you see here, B75 beam they have drawn, B86 they have drawn, great. Then they have drawn B95 because we had a B95 here, yeah. Then 104 and 113, yeah. Then again 104 and then 113, got it? So this is a cross section what which with that A section is cutting. So that is why all the beams has been shown here. Now you are seeing it from the front side, okay? That is why we can see only the depth and the breadth of the beam in this way, yeah. Now again, what else we need to understand from here? After this, how your reinforcement will start for the slab. Okay, so it will start from here. That means one is your bottom reinforcement. You can see this bar. This is not your beam reinforcement. Okay, you may get confused that this is not your beam reinforcement. Okay, this is your slab reinforcement only. You see, you can see the bottom here. Okay, okay. So what is given here? It is mentioned in the bottom. What kind of reinforcement? You can see the marking done here. Your two marking. One, you can see that dark circle, isn't it? So that is a distribution steel. I mean, not a distribution steel, because if it is a two-way slab, both are main steel. But for our understanding, I'll use a term called as distribution. But remember, if it is a two-way slab, both are main reinforcement. Now you can see here, this purple color, it is mentioned, you have to provide a 8 diameter bar at 6 inches center to center spacing. I'll draw it in this way so that we get a better picture once we finish this entire. Let me consider this is my slab, okay, and I'll consider this is my shorter span. This is my shorter span, and this is my longer span. Okay, always the bars will be placed in the shorter direction first. So again, I'll go with this thinking that my 8 diameter bar at 6 inches center to center by the main reinforcement. So I'll keep my, this is my 8 diameter bar. Okay, I'll keep it in this way, and it has been placed at 6 inches center to center spacing. Okay, yeah, got an idea? So this is my 8 diameter bar at 6 inches center to center spacing. Now come to this bar. So again, you can see it is in the bottom portion only. It's a distribution bar if it is a one-way slab. Otherwise, it is a main bar only, but it is in a longer direction. Again, here you have to make use of a 8 diameter bar at 8 inches center to center spacing. So practically how it looks, practically, let us say this is my 8 diameter bar. Now this has been placed at 8 inches center to center spacing. Okay, so my bottom reinforcement is done. Now come to the top steel. So this is your top reinforcement now. Got it? This is your top reinforcement. What is this line indicate? This is the center of your beam. If this is my beam, exactly from the center of my beam, I have to run this particular top bar. And how much extension it will go? 1 feet 6 inch. Okay, this will go up to 1 feet 6 inch. Similarly, at this portion, if you come see whatever I have drawn, no, this particular slab, only for this panel I have drawn. Okay, that is, this is okay. To put it in a better way, let me do one more thing. What I'm going to do is, yeah. So let us consider this is my B75. Okay, I'll draw it here. Yeah. Let us say this is my B75 beam. Okay, that is this B75, and I'll take one more color for B86 beam. No, I'll draw my B86 beam. I hope. Okay, I'll go with a different color. Yeah, same color there. Yeah, B86. I'll take this as B86. Now is it clear for you? Only this much portion only I've mentioned. I've taken it here. Yeah. Now you see this extra bar you have to provide. Okay. Now one thing you may get confused. In slab, how is that we are providing extra bars? We have different ways of providing a bar. You can give the top extra bar. Sometimes what we give is we give a crank bar, something like this, isn't it? In this particular building, we are not using crank bar, but we are giving a top extra steel. Now again, you can see here what is mentioned here. Up to 1 feet 6 inch, you are supposed to provide a 8 diameter bar at 6 inches center to center spacing. That means I'll give a top extra bar. I'll take a different color. I'll go with a black color now. So this much is my beam center. My beam center is here. I'll provide my top extra bar in this way. Okay, got it? Yeah. So till what distance it is going? Okay. Yeah. Yeah. Till what distance it is going to go? That is again mentioned in the drawing. Let us quickly do that. Yeah. So from the center, it has to be 1 feet 6 inch. Let us say from here to here, this distance will be 1 feet 6 inch. I'll write it here, 1 feet 6 inches. Got it? So this is your 1 feet 6 inch. Yeah. So again, it has to be a 8 diameter at 6 inches center to center spacing. Now, again, you can see one more distribution still given here. It's a 8 diameter bar at 8 inches center to center spacing. Now, where you're going to provide this steel? This steel will be provided in the top only, but this time you're going to change the direction. Instead of going in this way, you're going on the other side. That means this bar, no? This bar is going to come exactly here in this way. Okay, in this way it's going to come, and it will stop up to what distance? Up to this only. Wherever your this 1 feet 6 inch has gone, no? Up to there only this thing is going to come. Got it? So I hope your left portion is clear for you. Now come to the right portion. Here your extension will be up to 2 feet. This extension what you are going to provide, it is up to 2 feet. And for this we'll see what is mentioned. Yeah. Yeah. So this extension is up to 2 feet. Again, when it comes to the reinforcement, for the reinforcement you have to refer here. Okay. You can see this is your top extra, but it is going in this particular panel and also in this panel. So refer here what is mentioned. It is a 10 diameter bar at 6 inches center to center spacing. And for the distribution, it is not mentioned here. For the distribution, we can take this only, that is 8 diameter bar at 8 inches center to center spacing. Okay. Yeah. So what I'm going to do, again, in this direction also I have to provide. I'll quickly take this. I'll go with the black color. So it's a, see here, it is mentioned here. Okay. It is mentioned here, but it's the same bar which is going here also, right? So it's a 10 diameter bar at 6 inches center to center spacing. Again, I'll put it in this way. Extra bar. Okay. Yeah. Okay. So up to what distance it is going to go? It is mentioned here 2 feet. That means from this beam center to here it is 2 feet. It is 2 feet. Okay. Yeah. Good. And now again the distribution still you have to provide a 8 diameter bar at 8 inches center to center spacing. See, they have not mentioned it here. Okay. For this particular bar, you cannot see any, dimension. I mean, any of this is not representing the top distribution steel. In that case, you can take this only. In that case, in the sense, and usually distribution steel will be 8 diameter bar at 8 inches center to center spacing. You can go with that logic only. Otherwise, they should have mentioned it properly. Sometimes they miss it in the drawing, but you can make a call to the engineer and you can get it clarified. Since we are not clarifying, we'll go with the same thing, assuming that it's a 8 inches only, 8 diameter bar at 8 inches center to center spacing. Got it? So in this way, your slab panel is going to look. So in the bottom, in the center portion, you don't have anything. Only your bottom reinforcement will come. Now, what is the logic behind this? Again, for the very same logic, this particular slab is going to behave. That means we have a negative bending moment. We have a positive at the center. We have a negative at the support. So if I put it in this direction, so this is negative, this is positive, and this is negative. Since we have negative bending moment here, your slab will try to lift up. So that is why you have provided the top steel. This top, whatever you have provided, 1 feet 6 inch, that is your top steel, which will take care of this negative bending moment. Now come to the center portion. Center, you have only positive bending moment. You don't require the top steel. That is why we have provided only the bottom steel here. Now again, come to the this thing edge portion, that is here near the beam. Again, what has happened? Since it is a negative bending moment, you have to provide the top steel. That is why we have provided a top steel here. You can see here this up to 2 feet, this distance they have given. No, that is why you have to provide the top steel. Got it? So that is the main idea behind this. And with this logic, if you see any of the drawing from here onwards, it's the same thing what you can see. Right? So if I ask you to plot the bending moment diagram for this particular thing, obviously you will be in a position to draw it now. So quickly let me draw it. We'll start in this way. So we have a, see, always remember wherever you have this slab and a beam junction, your negative bending moment is going to come. So I have a beam here, I have a slab. Of course, it's a negative. I'll go with a different color. Yeah. and then we'll go with this. Yeah. So it's a negative bending moment. Got it? We have positive, positive. Again, from here, again, you are negative. And this is also negative because again, this is my beam. Here also I have a slab. Here also I have a slab. So this is a continuous. So you get a negative bending moment. Again, you're coming to the center portion, positive. Again, it is a negative, then positive. And of course, here it will be negative. Got it? So wherever there is negative, let me denote that with a different color. Okay, negative, 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 and negative. And wherever it is a positive, let me write this as positive, positive, and positive. Okay, if you want, I can draw one line which will bifurcate that. Okay, we'll say this is that line. Okay, above this is negative, yeah, positive. Got this? This is how the typical bending moment happens for all the slab panels. That is why this is how you get the steel. And wherever you just observe the trend here, wherever you have this negative bending moment, you can see all the top extra steel has been given. So if I want to, if I can bring it down, and now you see the trend. See, we had a negative bending moment. So you're providing a top left extra, top right extra. You had a negative, you're providing a top extra. Negative, you have an extra bar. Sagging bending moment, bottom steel. Now one question may come in your mind. Wherever there is a negative, you told that top extra steel will come. Then why is that? If I clear everything, I'll clear everything now. Yeah, I'll go with this. Yeah. So if that is the case, then why is that we haven't got a top extra steel in this portion? Because here also we have beam. Here also we have beam. Here also the bending moment should have been something like this. Here also the bending moment should have been negative, then the positive and the negative. Here the bending moment is also similar to that. But what has happened? Your 8 diameter bar, whatever you are providing in the bottom, that is sufficient to take care of your positive bending moment and the negative bending moment. That is why I don't require the additional steel here. Whereas in this portion, if I delete it, in the middle portion, let us say here, why is that we are giving a top steel and all? Because you can see a lot of negative bending moment, positive and then the negative. Here what has happened? Here also negative, positive and negative. But here the bending moment, whatever we are getting, no, the negative bending moment, it is a huge negative bending moment. If huge negative bending moment is coming, I require huge amount of steel. So that is why we are providing a more top steel here. Here also more top steel. Whereas if you come to this portion, if I delete this, whereas in this portion, the negative bending moment is very less. When there is very less negative bending moment, you don't have to provide the too much of steel. That is why you are not getting the top extra steel in this portion. Got it? So that is the main idea behind all these things. And that is how you're supposed to understand. I hope up to here your concepts are clear. I can take one more section to clear out, rule out any other doubts. So quickly, I'll take a small section. Okay. Maybe somewhere, no, almost all are. Okay, I'll go with a small section here. I'll go with the BB section. So this is my BB section now. If I cut it, which all beams I'm going to intersect? B74, B85 and B94. Only 3 I'll see. Okay, B74, B85, B94. So I'll go with the B section. This is section BB. You can see B74, B85, B94. And if I scroll it in this way, it will go up to here. You can see up to here. And what you can see here, see, it has mentioned here, you are getting a lift and a staircase. Maybe the same thing will happen here. If I go with the B section, we'll see what has happened. Exactly. You can see it is cutting up to here, isn't it? So you are getting a lift here. You're getting a staircase here. So no slab will come. And that is why they have shown it here. That is lift is coming and staircase is coming. Where there is no slab. Your slab will only end up to here. That is B122. So this is B122, wherever it is ending. Yeah. So you can see this particular beam is B122. Got it? Of course, after that, the rest things remains the same. Like I mentioned, okay. Whatever I mentioned, same thing remains. Okay. And this is a basement slab level. They are going to give the all those levels and all, from what level it will start and all. I hope up to here your concepts are clear. And now to make your things easier, yeah, I can show you. If you come here, so you get an idea. This was my plinth beam top level, isn't it? If you remember, this was my plinth beam. After the plinth beam, we had done the casting of the column, and whatever details we are seeing, that is a basement slab. So from plinth beam top to this, what is the height? It is a 10 feet from here to this height. Plinth beam top to here, it is a 10 feet. It is mentioned here. Basement slab top level is 10 feet level. Got it? Now, with all this understanding, I'll take you to a few of the practical drawings, so that practical site images for the same building which we had executed. So this is my retaining wall. Once the retaining wall is constructed, you can see these are my columns, and this slab centering whatever you can see, this is my basement slab. Okay, I'll take you to the next. You see here, retaining wall was done, and here they have put up the slab centering for the basement slab. So all these are your basement slab centering, all these things, the beam reinforcement, whatever we had seen, 16 diameter, 16 diameter, 5 bar at the top, maybe at 16 diameter, 3 bar in the bottom, everything they have arranged practically on the side. And yeah, now you can get a better idea. See, this is my plinth beam, agree, and this was a column what I casted, and this is a beam bottom what I'm putting. Okay, now if I go back to this particular drawing, it's the same thing which represents. See, this is my plinth beam top. Okay, I'll go in this way. Yeah, so see here, yeah, so this is a plinth beam top. This is my plinth beam top here. From here to here I have a column. So from all these other column, you can see here this is a column. Okay, and whatever slab I'm going to put now over this, I'm going to put the slab. Got it? So this is that level, and from here to here, from this the top of the plinth beam, from the top of the plinth beam to the top of this slab, till now it's not completed. This will be how much? 10 feet. Okay, that is how we are supposed to understand this drawings and all. Now again you can see here, yeah, so again plinth beam, all this works has been carried out. This is a lift pit, whatever lift we had seen it here. Yeah, in this drawing, where if I go back, yeah, so you can see here we had a lift portion, isn't it? Not this one, this lift portion. So we had a lift here, this much, 1 2 3 columns we had. So practically you can see that here, this is that lift portion what we are trying to understand. This was the column, this was the retaining staircase portion, and then we had few other drawings. Yeah, so again all these are the lift. Okay, lift column, 1 2 3 4 columns for the lift. All this were your lift columns. Yeah, that's how it is. Okay, so I hope you have got a better idea. Exactly. And now we'll come to this. We understood about the slab layout and all, right? If you remember, in the previous lecture I told you how to understand this basement roof slab layout. So if I, for example, if I consider this particular level, this is B51, then this is B110, B45 and B17. Why we need to understand this is because when you put the shuttering layout, so this is that shuttering layout, how it looks. Okay, so this is that particular slab which we are looking. If I put it in this way, yeah, so I'll go in this way. We'll consider this. Yeah, so this is that particular slab. Let us consider this is that particular slab. So this beam, whatever you can see, it is B44. This is that B44. Okay, B44, this beam somewhere here. Now here I have a B110. So this is my B110 beam. Okay, where is that beam? In this, inside this, that beam will come. Then we have B50 here. Let us consider this to be B50. And of course, on the left side, what is that? B100. So this is my B100 beam. Got it? So this layout will help me to arrange the beams and the slab centering practically on the side in this way, so that this carpenters and all can arrange all those across spans and all in the better way. And of course, all these things has been covered in my construction methodology course. I have completely explained you how all this practically on the site it was executed for the same building in a more better way with lot of site videos and all. Okay, yeah. So other than that, I think most of now coming to the reinforcement, you see the reinforcement now. Right now we understood the reinforcement, isn't it? That is how the section will cut and all. If I go back, yeah, so you can see this is how that was done, isn't it? B75, B86, and so you can see the practically the same thing will be here. If I strike it out, see here, you can see the bottom reinforcement here. Then this is your top left extra, top right extra. I mean, this is your top extra bars. What you can see, you can see the bottom steel here. You can see in the center portion in this way. In this way, this is your bottom steel which goes, and then this is your top extra steel. You can see from here, this is a top extra. From here also top extra. In the same way, on the other direction also, your steel will go in this direction. You can see similarly here also that direction of steel will go. Okay. So in this way, whatever was there in the drawing, the same has been executed practically on the site. Again, the same bending moment diagram also follows here. We know we have negative, negative, and positive, and that is how the execution is done practically on the site. We'll try to see how the ground floor layout has been worked out. See, again, it's very similar to the basement slab, but still, since we are trying to understand this as a whole structure, we'll try to see that once again. Okay. Yeah. So again, you can see it here. Ground floor roof slab layout, because your slab is done for the basement. Again, you have to put the column. You're going to raise the column. Then you're going to put the beam bottom, the slab centering, and the slab reinforcement you're going to put, right? That is how you proceed. Again, like I mentioned, now you can see the red color, the green, and the purple color, right? So here they are mentioned first floor slab to second floor column bar details. There's mentioned, like for example, if it is a C1 column, it is a red in color. Here, how do you differentiate that? If I try to zoom in, you can see this is red color, right? So wherever I have a red color, no, it is a C1 column. All these are C1, C1, C1. Similarly, this, if this is a purple color, if I'll go with the green color. Suppose, see, if I want to identify this green color column size, I'll come here. Let me zoom in. So this is a green color. So all these are my C2 column, which is of 8 number. And the last one is a purple color. If I zoom in, you can see the purple color. Again, C3 column, there's 17 number, right? So in this way, you get an idea how many columns are there of C1, C2, and C3, and what is the size and all. Again, the reinforcement details we know. Again, I'll not explain. Okay, how to understand this reinforcement details. So this is a complete layout of your ground floor slab layout, right? Yeah. Now, just to put it in a better way, now you can get an idea. See, this is how we started, right? Yeah, we started with the PCC, then we understood up to the footing reinforcement. Then after the footing, what happened? This was my plinth beam, and after that, after the plinth beam, what happened? We had put my basement floor, right? So this, I mean, yeah, this is a plinth beam. Your top of your plinth beam itself is your basement floor, okay? And from here we had this uh, basement slab, okay? From here we get a basement slab. This is a road level, okay? So yeah, this should have been a basement slab. This is basement floor they have written. Don't know. Yeah, third, second, first, ground floor, road level, RCC beam, basement floor. Yeah, I think this, see, I think they have made a mistake here. Maybe they have to rectify it, because if this is my basement floor, after this the first level will be my basement slab. Okay, anyhow, your basement slab itself is a ground floor. Yeah, it's right. Whatever they have done is correct. Okay, they have written basement floor, and this is your ground floor. Okay, because if you're standing in the basement floor, if you look at the top, it will be a ground floor only. Otherwise, you can call this as a basement roof also. One and the same. Similarly, if you're standing in the ground floor, and if you look at the top, it will be a first floor, or you can say ground floor roof details. Ground floor roof details and first floor both are one and the same. Exactly. So this is a complete elevation what you get. What is a floor to floor height? It is 10 feet 6 inches everywhere, and up the last one is your terrace portion. Okay, and this is your RCC beam, the RCC slab, and so on. Good. So next, again, this is your reinforcement details. Before that, we'll quickly see the plan. Yeah, we'll see the plan of your ground floor, how it looks. Okay, so we already seen, but still, in this particular lecture, we'll try to quickly go through this plan. It's written ground floor plan. This is how your ground floor plan looks. We have a staircase. The lift portion was here. We had 2 lifts here. Then we had a staircase here. So here they are making, they want to make this as a restaurant. They have a kitchen here. Then this is a corridor portion. Then they are going to make use of this shop, and shop. Again, this is everywhere there is a shop. Okay, and this is a corridor portion where you can make the movement. Since this is a restaurant, they have given a reception in this portion, and they have a reception here. Maybe an entry they can do from here, or even from here they can give an entry. Okay, from here also they can give an entry. Yeah, good. So this is how it is all about. Yeah, now we'll go to the beam schedule. Again, you know how to read this. We'll not waste our time here. Again, yeah, if I go back here, we know all the things will be given: B1, B2, B3, B4, B5. In this way, beams names are given. Quickly, you can, I'll pause it here. Just you can take a screenshot of this and try to understand. Any doubt you can ask in the comment section, or you can ask it in the question section. That'll be there to answer out if you're not able to understand or imagine any of this beam. Okay, yeah. So this is a complete schedule of a beam what they have given. Just go through all of this. If you're not able to understand, start from my first lecture where I've taught you this in a more better way. Okay, yeah. So once the beam is done, next what we are supposed to look, we are supposed to look the uh, yeah, that is a slab section. Again, for the slab, same thing. If I go back to the drawing here, they have cut a section like we did it previously. Again, this is A section, then we have B section which has been cut here, then we have a C section which has been cut here. So again, D section and so on. And similarly, what you're going to get is a ground floor roof slab sections. So if I come to the A section, only the beam number will change. Previously we had some B90 beam, here it is B75, because if I'm cutting this section, B75 is the first beam which I encounter. So if I go to AA, yeah, so this is B75, B86 and B95. So you can see B75, B86 and B95. Okay, and similarly now you are in a position to understand how the reinforcement has been given. It's almost same, since it's a commercial building like I mentioned. You can see the steel and all, everything remains the same. You can see there also we had 1 feet 6 inch offset. We had a 2 feet on this side, we had 5 feet on this side. It was a 8 diameter bar at 6 inches, 8 diameter bar at 8 inches. Okay, how much, what is the thickness of the slab? It is a 4.5 inch thick. Yeah, this is very important. See here they have mentioned the thickness also. That means if I go back, see here, yeah, okay, that is gone now. Yeah, okay, this is B75, which is 4.5 inch thick slab we have. If I go back, you see here, this is B75. You can see S1 4.5 inch thick. Next, what is the slab thickness? It is a 5 inch. Okay, so again you can see here 5 inch thickness is given. Similarly, next is again 5 inch thickness. Again, this is a 5 inch thickness. So in this way, you're going to get both the reinforcement details and also the thickness of the slab. So in this way, it will be easy for you to do the execution on the site, and rest all things remains the same. Okay, no much changes. Again, if you come to the section E, this is how the reinforcement has been worked out for E. B68, 77, 88, A97 and 106. Again, you can see how the reinforcement has been given here. So this is how we are supposed to understand. Okay, yeah. Similarly, if I come here, again same thing, there's nothing much to explain. Again, same thing, B70 and B79. Again, they are given the bottom steel, you have to provide 8 diameter bar at 6 inches center to center spacing, and this dotted one, that is a distribution or a main steel in the other direction. Again, it has to be 8 mm at 8 inches center to center spacing. Again, the same thing. Okay, so in this way you're supposed to understand the drawing, and that is how you need to do the execution on the site. And the last drawing what we have is the electrical drawing. Okay, once you're done with the slab casting and all, before you do the slab casting, the electrical people will come, and we have to give the layout to them so that they can put the junction box accordingly. So here they are given the electrical, this drawing will be taken care by the electrical people. They'll come, and wherever the junction box has to be kept and from where the wiring has to be passed, all those things will be done by them. Okay, it's written here ground floor electrical layout. So all this is electrical layout, where like here is a junction box, from here you are going to take it, all these things you are going to take, and you have to pass it through this particular beam. Okay, so in this way you are going to do. Again, to get a better picture of this, on the construction methodology course, I have explained all these things through a practical site videos and all. So you might have seen that, or if not, you can even enroll in that course and get more knowledge regarding that. Okay, yeah. So that is how it is. So we have completed the ground floor also, and most of the things we are able to understand. Yeah, try to see how the first floor, second floor and the third floor is going to look. Okay, so we'll start with the layout again. So again, it's written here first floor roof slab layout. So everything is same, only the thing is that here we have this sunk slab, right? What is this sunk slab? You can, if you see it here, you see here, so here we have a slab, like the toilet is going to come in this portion. So that is the reason they have written it here sunk by 13 inches. Okay, we can see IB stand for intermediate beam. Okay, this is B1 and all. And then you can see sunk 13 inches, sunk 13 inches, sunk 13 inches and all. Whereas here it is 5 inches, right? That means this slab level will be 13 inches down from the top of the beam. Whereas this will be 5 inch. It's a 5 inch slab. I mean 5 inch thick slab, whereas this particular thing, what you can see now, 13 inches in the sense from this level, it will be 13 inches down. So if I want to put a cross section of this, yeah, let me do that. So let us say if this is one portion, okay, okay, yeah, yeah. So if this is one slab, okay, let us say this is slab for me, normal slabs, and this is also slab top level. Wherever there is a sunk portion, no, so in the sunk portion it is mentioned 30 inches down, isn't it? That means from here to here it is 13 inches down. So you can see sunk by 13 inches. So this will be 13 inch. This will be 13 inches. Got it? Yeah. So this is the bottom level now. So this is the bottom level of a slab. So this is a bottom level of a slab, and this is a top level of a slab. So why this sunk? We know that wherever there is a toilet portion and all, we need to take the plumbing lines. So that is the reason we will try to sunk this slab. Okay. Other than that, rest all remains the same. Nothing changes. Yeah. Yeah. See, you can get a clear idea from here. Leave 6 inches sleeve, that is PVC pipe in the beam before the concreting. See, this is a slab top level for you. This is sunk by 13 inches. Got it? So in this way it is mentioned. Yeah. So IB is an inverted beam. Yeah, IB stand for inverted beam. So right. So in this way, inverted beam in the sense on the top of the slab, your beam is going to come. So it is an inverted beam. Like for example, see, you can see a beam here, right? That is a 9-inch by 9-inch beam. Okay. So this beam is going to come over the slab, over this particular slab. Hence it is called as inverted beam. Okay. It is called as inverted beam. Yeah. So other than that, rest all things remains the same. Nothing change. Wherever there is a sunk portion, they have given sunk and sunk. And here, this particular beam is going to come. Okay, that is the inverted beam. This beam will be above this particular level. Okay, over this particular beam, or let us say above this particular slab, your beam will be resting. Got it? So that is why it's written IB. Yeah. So other than that, nothing much to explain. Rest all remains the same. Okay, wherever staircase, lift, and all those things are same. There's no much changes here. Yeah. Again, same thing. S1 is a slab. The thickness of the slab will be given, which is surrounded by 4 sides of the beam, and the beam dimensions will be mentioned here. Yeah. Now we'll go to the cross section part. Again, same thing. We'll not go in too much, depth here. Again, it's written first floor roof slab sections. Again, same thing. Wherever the section has been cut, like this is a section FF now, section GG. So you can see even in the section how the sunk slab will look. So if I try to zoom in here, yeah, you can see it here, no? See how the sunk slab has been put up. So this is a sunk, which is in this way, and this is a reinforcement which has been given to that sunk slab. Okay, so this is sunk. You can see this bottom level. This is a normal slab level. Sunk slab level will be at this level. Okay, yeah. So again, rest all remains the same, like we understood in the previous slab drawings. Yeah, nothing much to explain. Everything is same. Okay, yeah. So once that is done, again the electrical layout. Again, electrical layout is also very simple. Again, it's not our main concern. The electrical people will take care of this. But again, we are looking as a drawing. Again, it's written here. First floor electrical layout. Next, we'll go to the beam schedule. Of course, I should have taught you the beam schedule first. Again, all these are the beam schedule for that. Okay, first floor beam schedule like B1, B2, whatever beams it may be. It is mentioned here. What is the size and all those things here. So next we'll go for the second floor roof slab layout. Again, second floor roof slab layout is also similar. Nothing much changes. Wherever there is a sunken slab, now you can see here we don't have sunk slab based on the architectural requirement. Maybe they are not putting any toilet in this portion. That is why we don't have a sunken portion here. So wherever you are putting a toilet, no, that is where the sunk portion comes into play. Again, we have a sunk here, sunk here. So in this way, they have given the sunk portion. You can see. Other than that, the rest all things remains the same. Column and all. Yeah. So again, few remarks they are going to put, like you can see this column, like this column, this column, this column. What they have written? Column stops up to the slab level. That means in this particular structure, what actually happened is that, yeah, let me show it to you. Yeah, so you can see here 1, 2, 3, 4, 5. This 5 columns, you are not going to raise it. That means which floor right now we are. So in the second floor itself, you have to stop this column. It's written here, second floor roof slab layout, right? So this column will go and stop at the second floor level. Okay. Yeah. So that is why you can see now this is my basement slab. This is my ground floor slab, or this is my first floor. This is my second slab. This is my second floor. Okay, right? And this will be a third floor. Now whatever columns you can see inside now, these columns will not further raise. That is why it's written, see, this two column, this column and this column represents this column, this column and this column represents this and this column. Whereas this and this column, of course it's not visible for you from here. From here onwards, no, you are not going to raise the column. So it's written here, column stops up to the, what is written, slab level. If you see a column stops up to this slab level, right? Why is that so? Because after that, in the next floor, this entire area, we are going to make use of this entire area as a function hall, as a party hall. So since we are going to make use of this as a party hall, we why is that you don't want the column? Because since it's a party hall, if I put the column, then there will be a lot of obstruction. There is no free space available. That is why 1, 2, 3, 4, 5 columns we are removed here, and then we are going to rest our beams completely on this column and on this column. When I come to the third floor, I'll show you that these columns will not be shown in the drawing. Got it? So that is how you have to understand the drawing. So this was about the second floor roof layout. Rest all things remains the same. Only the wherever the cutout and wherever the sunk slab is given, that we are supposed to understand. Yeah. So this was a plan of that second floor plan. This is how it is. Okay. We have seen that initially. Then it is a hall. We have a hall in this portion. Rooms, and the lift portion and all. Since it's a commercial, sometimes it keeps on changing based on the client requirement. Okay, and all those things. So that is why when the designer designed it, he designed it for the worst case. Because let us say after some time the client feels like he don't want to make this as a room, he want to make it make this particular area for some other purpose. Got it? So in that is the reason what usually happens is when we take the load and all, we take it on the higher side, so that tomorrow we don't have issue once the structure is built. Yeah. So next, this is a this thing. Yeah, beam layout we had it here. This is a beam layout for the second floor. So it's mentioned here. This is a first floor roof beam schedule. Yeah. Okay, second floor we had it here. It's similar, again it's similar to that. Okay. Yeah. Now we'll go to the third floor. Now we'll go to the third floor slab details. Yeah, you can see it here. Yeah, now we are into the third floor roof slab layout. Now you see that changes whatever I explained you now. So those columns has been vanished from here, isn't it? If you observe it here. If you observe it here, you see we don't have any columns here, right? These two columns we have initial, these two columns, whereas this columns has been vanished, right? So that is why the column was stopped up to the second floor. Now right now we're in the third floor slab layout. So that is why you can see the column everywhere, and we don't have column in this. Now what will happen? This particular beam, no, this particular beam will be resting on this column and this column, this column and this column. Now you see the size of the column. Since the distance has increased, what will happen? Your depth of the beam will also increase, right? That is why if I go back to your second, you see the size, it's a 12-inch, breadth remains the same. Look at the depth, it is a 30-inch here, right? Similarly, this is also 30 inches. Whereas in the second floor, what used to happen? In the second floor, you see the depth. It was actually how much? 12-inch by 18-inch, 12-inch by 18-inch. Now you have removed the column. Since you have removed the column, now we'll come to the interesting part of structural engineering. That is, since you have removed the column, what will happen? The L/D ratio will increase now, right? Because see, whenever you decide this depth of the beam, usually the depth of beam, we try to keep it between L upon 10 to L upon 12. What is L? L is a clear span what you can take. Okay, L is a clear span. So since your span has increased now, since the span has increased, because you have to rest it. If I so since this span has increased, now you have to rest your beam from this column to this column. This span has increased, isn't it? If the span has increased, again what will happen? Depth of the beam also will increase, because if you see it from here, depth of the beam is directly proportional to span. L is a span of that. That is a clear span. So that is why you can see 30 inches given here. Got it? So that is how it is. So that is why usually when we try to keep the column spacing, we try to keep it like 4 to 5 meters center to center distance, so that what will happen, your structure is economical and depth is also not more. When you don't have a column spaced at a closer spacing, like you can see how far it is placed compared to the second floor, now what has happened, the depth is going to increase. But again, it all depends, since you need it here, right? Because my main intention is that I want to have very clear space here. I don't want to obstruct my this particular floor with a column. That is why I removed the column. Since I removed the column, the length of the column to column has increased. Since the length has increased, that is I has increased, the depth of the beam will obviously increase to satisfy the deflection criteria, right? So that is how it is. That is how the designs are done actually. Okay, yeah. So other than that, rest all things remains the same. Okay. I think again, no much explanation is required here, because we already understood that. Yeah. So next after this, we have a beam schedule. This is a cross section of that. Again, you can see it here. Third floor roof slab section. Again, you know to read the slab sections and all. Same thing is given here. The bottom steel, top steel. Again, how much extra you have to give, and all those things like B1, B5 beam, bottom steel. Then again, another longer span, shorter side. Top extra bar, how much it has to go, 1 feet 6 inch. From here, how much it has to go, 1 feet 6 inch. All those things will be given in the drawing, and based on that, the execution will be done on the site. Again, the last is the third floor roof beam schedule, which I should have taken earlier. No problem. Again, this is the roof beam details. Now you can see it here. Again, all the beams have been given, sizes has been given, and wherever whichever sizes are coming, based on that you are going to do the execution. All the stirrups and all will be mentioned here. Okay, so that is how you are supposed to understand the structural drawing. And this was the last drawing what we had in the entire basement plus ground plus 3-story building. Right now we are in the third floor. So that is what we have seen now. Complete all the details and all the drawings we have seen. Try to see how the staircase layout is given. So far we have understood about all the slab details, the beam, the shuttering layout and all, right? So the last part is about the staircase part. Now, if you see, this is a plan of my staircase, and this is a cross section for that. Okay, so first we'll look into the plan part. Again, this particular staircase is supported on 4 columns. I have a column here. This is my another column here, and another column here. 4 columns. So up in the sense, you're going to take a flight. This is my first flight. This is my landing portion, and this is my second flight. Got it? So it's a kind of a clockwise in this direction, and it is a good way to put a staircase. Right now, see, we have this particular beam, isn't it? We have a beam in this part. You can see B21 is written, and they have written a B22. So it's called as a mid landing beam, because what will happen is that you see here. See, this is my floor to floor height, right? This is my, like, see, this is the top of a plinth beam, agree? And from here, this is a basement slab. So this is a floor to floor height, which is 10 feet. But when you go with the flight, since I require 2 flight in one floor, right? That means this is flight number 1 and this is flight number 2. I need to give one particular landing here. That means I call this as landing, and this landing will be supported on a beam, because I'll be putting up beam, and over that this particular slab will be resting. So that is why you can see it here. This is called that mid landing level, where we have a beam of B21 of 9 inch by 21 inch, and B22 which is 9 inch by 21 inch. Got it? So this is that particular portion. Got it? You can see it here, B21 or B22. Since we are seeing it from the front side, you can only see this particular portion, whereas this is a beam itself. But from the plan, it is quite clear for us. So this is my flight 1. This is that flight. Okay, up to here, this is that flight. This portion, what you can see, it's this particular landing, and this flight, what you can see, that is this particular flight. Okay, got it? Yeah, great. Now coming to the sizes of the beam, because I need to understand, right, what is the size of the beam, what is the reinforcement I'm supposed to give. Now the question may come, why is that this B21 and B22, they are given in the staircase portion? Since it is a beam, they should have given it in the beam schedule. They didn't give it, because this belongs to the staircase part. So that is why you will see such kind of beam, that is a mid landing beam, in the staircase drawing only, and not in the beam schedule for a first floor, second floor and all. Okay, so that is why it's mentioned here. So 9 inch by 21 inch, 9 inch by 21 inch. Again, the bottom steel, it's understood now. we need to provide a 16 diameter 2 bar straight in B22, and in the mid span you have to provide 16 diameter 5 bar, that is a top steel. Got it? And then there is no extra bar. Similarly, when you come to B21, come to the bottom steel. So this is bottom steel for you. 16 diameter 2 bar you're supposed to provide. Along with that, I need to provide a 12 diameter 2 bar, that is a curtailment bar. Okay. Coming to the top steel, I'm supposed to provide a 12 diameter 2 bar which will go straight. Then on the left side, that is a top extra steel at a continuous support. Okay. So where is a continuous support? So if I take this particular column, so this is my continuous, because on this side also I have a beam, on this side also I have a beam, right? So this becomes my continuous portion. You're getting my point now. See, just concentrate on this beam. Where is my B21 beam? So this much is my B21 beam, right? Now identify which is a end portion and which is a continuous portion. Now for this particular beam, this column is my end column, whereas this column is a continuous, because over this side also I have a beam, right? So we come here, extra steel at continuous support and extra steel at end support. You're getting my point? So that is why if I come here, extra steel continuous. Now this is my continuous support, isn't it? So here you're supposed to provide 16 diameter 3 bar. That means in the top portion, I'll give 16 diameter 3 bar. Let me quickly draw that. So 1, 2, okay, 3. This is 16 diameter 3 bar, which is extra. And extra steel at end support. Where is the end support? This is the end support, right? Because beyond this, you don't have a beam running. So this becomes my end support. Here I'm supposed to provide a 12 diameter 2 bar. So I'll provide a 12 diameter. This is 1 bar. This is 2 bar. It's an extra bar, okay? Anyhow, your 12 diameter 2 bar will run continuously in the top portion. Along with that, this is extra bar which is given. Got it? Yeah. Other than that, the rest things is very simple. Coming to the stirrup part, you're supposed to provide 8 diameter bar everywhere, 8, 8, 8 and 8, and the spacing at the support and at the center, you're supposed to keep it as 6 inches center to center spacing. That's it. Very good. Now yeah, other than that, one thing we can identify, see, they have given a remark here. It's a cantilever. That means your B22. Which is a B22? This is my B21. Whereas this particular beam, I'll delete this particular beam is my B22. This particular beam is my B22, and it's a cantilever. Agree, because see, if this is my beam, this is fixed support, so one end is fixed but this end is free. Okay, you have a beam in this direction, but it's a cantilever. You don't have any column here. So that is why he has mentioned this as cantilever. And the moment I say cantilever, one thing should come in my mind. What is that? You should understand the bending moment. If this is my cantilever beam, okay, so how would be the bending moment of this? The bending moment of this will be completely negative, right? So this is a negative bending moment. Negative. That means when I say negative, I need to provide top steel. So that is why if you observe here, if I bring it to the top steel portion, see, sometimes what happens in the drawing, they may give wrong. Maybe not wrong in the sense, maybe the person who has drafted this drawing in a hurry, he may not give proper steel. But as a site engineer, or maybe as an engineer, the moment you look into the drawing, you should get that conclusion. Okay, since it's a cantilever, I should be getting the top steel. So that is why if you concentrate here, just concentrate in this portion, it is enough. Okay, see here what has happened. Come to the top steel. In the mid span, they are giving a 16 diameter 5 bar. Why is that 16 number of 5 bar has come in the mid span, and especially in the B22? Because it's a cantilever. We have negative. I mean, we require top steel. That is why in the top steel, in the mid portion, you are providing a 16 diameter 5 bar. That means more steel is coming. What I'm trying to tell is, now come to this B21. Whereas your B21 is not a cantilever. The moment it is not cantilever, what kind of beam it will be? It's a fixed beam, because I have a column here. I have a column here also. So what would happen? This becomes my fixed beam. So in this, what will happen? Fixed beam. It depends how the steel will come. But you can see the number of steel here. You have got 12 diameter 2 bar, right? And along with that, you have extra steel and all. But here you are not providing a 16 diameter 5 bar like you did it here. Why? Because since it's not a cantilever, you don't get a complete negative bending moment there, right, at the top. So that is why the steel has come down. Got it? Now let us say, why I'm trying to tell this is that, now let us say tomorrow you're working as a site engineer, or maybe you got this project. Okay, now maybe the engineer, instead of giving a 16 diameter 5 bar here, he might have given let us say instead of giving the 16 diameter 5 bar here, he might have given that here. I'll do it in this way. We'll take it out. I'll write it here. So instead of giving that 16 diameter 5 bar there, in the bottom he might have given that 16 diameter 5 bar. Okay, let us say in the bottom, that engineer, some draftman might have made some error. and he has given 16 diameter 16 diameter 5 bar here, and I'll take it out, and I'll take this out, and I'll make this as, I'll make this as like, 12 diameter 2 bar. Let us consider. Okay. Yeah. So what has happened now? The moment you see cantilever, that thing should come in mind, because on the top I need to provide more steel. But here what has happened? You're providing more steel in the bottom, that is 16 diameter 5 bar in the bottom, and top you're providing only 12 diameter 2 bar. So practically this is not possible. So then you can call up this particular structural engineer and ask him whether there is any mistake being done in this particular drawing, because you know the concept now. And of course he will convey you that, yeah, there is a mistake in drafting. Then he may give us what you call a corrected drawing. Again, why I'm telling this? Because once the beam is casted, no one can come and take it out. I mean, again, there's an extra cost involved in breaking and all. So if you have such kind of judgment, if you have the fundamental strong, even before the executing, even though there is a wrong in the drawing, you can take a decision on the side and saying that, okay, this is not right what they have done, maybe this should have come here and this should have come here. So this decision can be taken at the side. So that is why all these fundamentals are required. Yeah, anyhow, this is understood. Now coming to the this thing, that is a cross section. It's very simple. So this is a plinth beam, level 00, in the sense from the plinth beam itself you are going to take the bar, that is a double bar. If you remember, at the time of plinth beam I explained you about the double bar, right? So this double bar will be inserted here itself, and from here your bar is going to be taken. Okay, and what kind of bar you're supposed to provide? Again, this bar is your main bar, which is a 12 diameter bar, which is provided 6 inches center to center spacing, and these are your distribution steel, okay, which is provided, that means it's a 8 mm bar at 6 inches center to center spacing. Got it? And up to here you're going to come, and always remember this bar you're going to bring it up to here. Okay, always you have to remember such things. See, when you're bringing a bar, go with a different color. Yeah, so this bar has come, it will come here. Okay, it will come here, and from here it's going to take a bend. Okay, why is that so? You're not bending it somewhere here. You could have bent this bar here also. You could have brought the bar and you could have bent, and you could have taken it here also. No issues in that. But what would have happened? Since if I try to zoom in, yeah. So what has happened? See, when you try to bend here, no. Now what? See, first I'll go with this. Yeah. Now since here you are bending, now what will happen? This, when the load comes, this will try to open up. This particular portion will try to open up. Okay, so it will try to open up, it will try to put a force here, it will try to open up, and it will try to put a force in this direction. Okay, the resultant, because it will try to pull in this direction, it will also try to pull in this direction. The net resultant you are going to get in the downward direction. So if you don't have enough concrete here, what will happen? The crack is going to come. So now what has happened? We have taken a bar at the top. No, now what has happened? This much amount, this much concrete is there for us. This much amount of concrete is there. So this resultant force, what is coming? It is able to, this concrete is this, whatever thickness you are given, no, the base slab thickness, I mean the landing slab thickness, it is sufficient enough to take care of this resultant force. Now the question is that what will happen if I don't bring this bar to the top? Okay, now the question is that what will happen? Now let us say, instead of bringing the bar here, okay, yeah, I brought a bar here, and I didn't take it to the top, I brought it here. Okay, and then I took it something like this. Okay, got it? So few of the construction site people do this, they don't have idea. Instead of taking it completely here, I'll go with a different color now. See, instead of taking this bar here and then giving a bend here, what they would do, they would bring a bar here, and from here they would have taken here. Now what will happen? Very simple, I told you that there's a resultant coming. Yeah, okay, I'll do it once again. Yeah, come here. Yeah, so what will happen? The resultant force, where it's going to act, the resultant force will act here. The resultant force will act here, right? So the moment the resultant force act here, how much amount of concrete? Very little amount of concrete you have, no? You can see this gap compared to this gap. Here the gap is very less, the thickness of a base slab is very less. So what will happen? The cracks are going to form here. So that is why always when we do the detailing of a staircase, we don't try to bend the bar here, we try to take it to the top. Similarly here also, similarly on the other side, you can see, yeah, where is the other side? Yeah, one is this one. Yeah, your bottom bar will go here and it will get bent here. Similarly here also, same concept. Here also you have brought, here also you have brought a bar and here you are bending it, okay, and then you are bending it here, right? You're not bending it here, you're not bringing the bar here, and from here you're not bending again for the very same reason. If you bend it here again, that resultant force whatever it will come, it will try to pierce here, and then what will happen, the crack will form. That is the reason we always try to take the bar to the top, and from here now what has happened, you have enough what is that thickness there to resist that particular force. Okay, same here also, you see here also you have bend it here so that you have enough thickness here. Got it? Yeah, so that is the logic behind that. And other than that, I think yeah, this is your landing slab now, and from here this is your next flight. So all these things are risers and thread. We know the what is riser by this time. So this vertical is called as riser, this horizontal portion is called as thread. Okay, and then this is your second flight. In second flight also again same reinforcement you're supposed to give. You're supposed to provide a 8 diameter bar at 6 inches center to center spacing. Okay, that is your this thing, the distribution one. And your main reinforcement will be, of course, the, yeah, here both the thing, yeah, main reinforcement should be, yeah, it's written here, yeah, it's a 12 diameter at 6 inches center to center spacing, this one. Okay, this is the main reinforcement. The distribution is 8 dia at 6 inches center to center spacing. And here this is that portion, how much extra portion you have to take, it's 3 feet 6 inches. From here also it is 3 feet 6 inches. Got it? So in this way entire thing will be given. Right now from 0 to basement slab they have given, then again from basement slab to the ground floor slab, again it's the same continuous thing. Here they are not given. Again from ground floor to first floor, first to second, same thing is going to get continued. Okay, I'll be taking you to few of the drawings of our industrial building, and we'll try to see how those drawings are worked out. Okay, so I'll be sharing you that drawing now. Yeah, so this is a footing layout what I have. Then they have given the footing dimensions, that is a schedule of table. Then they have given the column reinforcement and other things. See, most of the things remains the same, but there are few things which we can learn from each of the drawing so that we can understand most of the drawings. First, I'll get into the footing now. So if I try to zoom in here, you can see footing is given. Again, it's very simple. F1 footing is given over that C1 column is going to come. F2 footing C1 column, F1 C1, F1 C1. Okay, F2 footing C1, F1 C1, and also the dimension is given. Got it? I hope this much is clear for you, right? So in this way, all the footings has been given. And you tell me what kind of footing is this? It is a sloping footing, because you can see a slope has been given. It's called as a sloping footing. Now to understand the cross section of this, what I'm going to do, I'll take you to the cross section part of this footing. Yeah, it is here. See here how it has been given. So this is your finished ground level. That is from here you are going to do the excavation. Great. And now this is your PCC, 75 mm thick PCC, and it should be made up of 1:4:8 grade of concrete. Got it? And now since it's a slope footing, we know that we are going to get two depth. One is D1, which is the overall depth of the footing. Another is a D2, which is only the rectangular portion. That, like, this is my rectangular portion. So this is, yeah. So this is my rectangular portion. And after that, whatever I'm going to get, this much portion, the top portion, it is a slope one. So how do you find this area? We know. Very simple. How do you find from here to here the distance? D1 minus D2 is going to give me this distance. Got it? Yeah. And now they have mentioned all these things, like D1 is this complete depth, D2 is this depth. Then what is D4? D4 is from column outer to this part. This is D4. Okay. All those things it will be written in the drawing. Based on that, we have to do the execution. Great. Yeah. So we understood the footing layout now. We'll go to this thing, that is a schedule of footing. We'll see what is given in the schedule of footing. I'll take you to that. Yeah. So what is written here? Schedule of footing. Footings is given F1 and F2. How many numbers? F1 we have 16. F2 we have 8 numbers. Breadth is given. Length of the footing is given. And you can see here D1, D2, D3, D4 is given, right? And you see the breadth is 2300 mm. Length is also 2300 mm. Now what is this D1? So this D1 is the overall depth of your foundation, which has to be 600 mm. What is D2? D2 is that straight portion what you have. And what is this D4? D4 is this portion, right? So if I come to the D4, yeah, okay, great. So you can see here, D3 is this cantilever portion. Okay, not the cantilever portion, like if I want to put it in a better way. So here you cannot see that D3, right? Because if you're seeing your footing from the top, see this particular thing, what you are able to see here, right? This particular thing, what you are able to see, that is D4, it is mentioned here. Similarly, on the other side also you'll be having a D3, right? So that is this portion, okay? That is from the outer of your column. That is from your outer of your column. How much is this distance? It is mentioned here. This is D3. This is along the length side, and this is D4, which is along the breadth side. So that distance I mentioned it here, and it's going to be same, right? It's going to be same. You can see D3 and D4, it is 500, 500. And here also you can see it is 550 and 550. Whereas D1 and D1 both are 600 mm. D2 is also 200 mm. And your D3 is 500 mm. Got it? I hope this much things are clear for you. And then coming to the reinforcement. So they have given the reinforcement here, B1 and B2. Again, what is B1, B2? You have to come here and check what is B1. So B1 is you are going to provide the steel in the, yeah. B1 is that you are going to provide the steel in this direction. This direction steel, whatever you are going to provide, it is called as B1. And the steel which you are going to provide in this direction, it is your B2. From here to here, you can see this one. So this is your B2 steel. Got it? So they have given it here. Yeah, they have mentioned it here. B1 and B2. So at B1 in F1 footing, you're supposed to use a 12 diameter bar, and center to center spacing is 150. Like this is 150 center to center spacing. In B2, you're supposed to use 12 diameter bar, and the center to center spacing is 150. This has to be 150. Similarly, in F2 footing also, you have to do the same thing. That is, spacing is same, provided the steel is different. Here you're making use of 12 diameter. Here you're making use of a 16 diameter and 16 diameter. And obviously, you see why that changes is happening, because the F2 footing size is much greater compared to the F1 footing. Since the size is greater, it means more load is coming. If more load is coming, more steel, more bending moment, and more bending moment means more steel is required. That is why what they have done is they made use of a 16 diameter bar. Here the load was less, they made use of a 12 diameter bar. And this is net SBC. This is not required for you, but a structural consultant, for him it is required. If you're working as a site engineer, then this part is of no use to us, okay? Which is 150 net SBC what they have given. Great. So up to here our concepts are clear. Now we'll move to the column part. We'll move to the column part. Again, in the column, they have given it here, schedule of column reinforcement, C1 column, C2 column, C3 column. And in C3 column, what they have mentioned, C3 is a stub column. Stub column in the sense, these columns don't have any foundations. They are like floating columns where you are going to take them from the beam or somewhere above the ground level. You don't have a footing to that. So it's mentioned C3, which is called as a stub column. Great. Now coming to this reinforcement, see, the size is 400 by 450. The size is 400 by 450. And this size is 300 by 300. Coming to the reinforcement part, you can see all the dark patches here, or the dark circle. All these are your reinforcement. Now, how do you understand this? They're given a number like 1, 1, 1 and 1. So wherever the 1 number is given, that means 1 indicates that you have to provide a 20 diameter 4 number of bar, because 1 is written here. Now coming to the 2, where they have written 2? 2 is written here, 2 is written here, then again 2 is written here, 2 is written here. Again 4 number of bar, isn't it? So again you can see a 20 diameter 4 bar is written here. That is 2 number. Okay. Now again search for the 3 number. So 1, 2, 3, 3 number, and another one is here, another one is here, right? I think, yeah, sorry. See, 1, 3 is here. This is also 3. This is 4. Okay. And 3 and 3. 4 number. So you're getting my point. Again, you have to use a 20 diameter bar, 20 diameter 4 bar here. Okay. Then coming to the last one, that is a 16 diameter 2 bar. So where is the 16 diameter 2 bar? How do you search it? Search for the number 4. The number 4 is here 1, and this another here. So 2. So here you are going to provide a 16 diameter 2 bar. Got it? So in the same way, I'll do it for this quickly. I'll try to, let me try to decorate this a bit so that you get a better understanding. So 20 diameter 4, wherever this is 1. Okay. I'll do it here. 1. The yellow color is my, yeah, 20 diameter bar. I mean, yeah, it's a A1. Okay. I'll do it in this way so that you get a better understanding. And for 2 number, that's a 20 diameter. This I'll decorate this with the red color. That is 2. So wherever there is 2, this is 2, 2. Then I have 2 here. Got it? Next, for the next one, I'll go with the green color. Wherever there is a 3 number of bar, so 3 is here, 3 is here, 3 is here, 3 is here. Got it? Which is left one now? The last one is left out. So I'll go with the dark color. This is 4. Okay. 16 diameter 2 bar. That is 1 is here, and this is second. Got it? So in this way, you're supposed to understand it. Again, this is very simple. The last one, I'll not do for that. Yeah. Now we'll go to the lateral ties part. Lateral ties are a bit interesting. So coming to the lateral ties, what is mentioned in the lateral ties? Yeah. So what is mentioned in the lateral ties here? See, so you have to provide a 10 diameter bar at 75 mm center to center spacing. Okay. And you have to provide a 10 diameter bar at 75 mm center to center spacing. That means you're supposed to, you're making use of 2 types of lateral ties. One is your master ring, which will go completely. Then there is one more ring. How do you represent that here? It's mentioned here. Your complete ring, that particular ring will go here. This is the first ring, which will go completely. And then next ring, it is going to go here. Yeah. Next ring, you can see it here, here and here. This is your next ring, which will go. Okay. Not the ring, that is called as ties. This is called as ties. Got it? Now, similarly see here. Here also you have a master ring and a tie. You can see it here. This is your master ring. Okay. And then you have a tie. Tie will make use of a different color. This is one tie. Another tie they have given it here. Got it? Here it's very simple. They have only one master ring and only one master ring. They are supposed to show it here. Now, why is that they have shown even this also? So what is the reason behind that? We'll try to understand. The reason is that, so for that we have to come here, and if you see here, yeah. So I'll go in this way. Okay. See, this particular zone, can you see that is from the bottom of your beam to the top of your beam. Okay. This particular area, right? So this is that length what we have from the bottom of your slab to the top of this slab. Okay. This is one complete length what I have. So the code says that if you refer earthquake detailing code, that is IS 13920, which is for the ductile detailing, it says that, okay, from here to here, this much portion what you have, and from slab to this much portion what you have, no, you're going to do the confining reinforcement. That means here you're going to keep the lateral ties, that is your stirrup. In column it is called as lateral ties, at a very lesser spacing. Okay, so that is why you can see your lateral ties here, they are placed at the very close spacing. Okay, since it's an earthquake, since we are putting the structure in the earthquake resistant zone, we want to make the zones as a ductile. I mean zones in the sense wherever there is an interconnection, because this is a slab and this is a beam ending, right? So this zone I want to make it more ductile. So more ductile I can give by providing more reinforcement and at the closer spacing. Similarly here also I'm going to do that, closer spacing. Okay, got it? Whereas in the middle portion, this middle portion, that means this is my middle portion. I'll go with the, you can see something is written. What is written? Normal zone. They have written it as normal zone, this much portion. Okay, this is called as normal zone. Here we don't require more steel, so that is why what they have done, they have increased the spacing here. you can increase the spacing. This spacing you can increase. You can see the spacing has increased in the lateral ties. Got it? Right? So this is how it follows in everywhere. Similarly, if I come here, you see the same thing you can see here also. Yeah, like if I go to the top, not here, I'll go to the top now. Yeah, I'll go to the top. We can delete everything. See here also it's the same thing. Like if I come here, see, this is the top of the slab and this is the bottom of the slab. From here to this distance and from here to here distance, it is confining zone. Okay, and your middle zone is a normal zone. So this till what height you are supposed to provide, they are going to give the length that L0 is equal to 450 mm. That is from the top of your slab up to 450 mm. You are supposed to give your lateral test at the closer spacing. Similarly, from the bottom of your slab, okay, not the bottom of the slab, bottom of your beam. Okay, from the bottom of the beam to this length, it has to be 450 mm. And here you have to give at the closer spacing. Remaining you can give the normal zone. Now, how do you understand that? For that, they have mentioned it here. That means, see, ties or links at confining zone and ties at normal zone. Now you understood what is confining zone. This is my confining zone. This is my confining zone. This L0 and the L0. This is confining zone. And the middle portion is a normal zone. Got it? So when you come here, it is mentioned here you have to provide a 10 diameter bar at 75 mm center to center spacing. Whereas in the normal zone, you have increased the spacing, which is at 8 diameter bar at 300 mm center to center spacing. Similarly, here also you see that links also same thing. Links also same thing. 10 diameter bar at 75 mm center to center spacing. This is at 8 diameter bar at 300 center to center spacing. Got it? Similarly, for this column also, that is the column C2, they have done 10 diameter bar at 75, but here they have increased the spacing. That where they have increased at the normal zone. So what was the reason behind that? Since the zones where we want to make it more ductile, we are providing more reinforcement and making it a more rigid zone, right? So that is the main theory behind that. So that is why we do, and we don't do all these things of detailing everywhere. Wherever there is an earthquake resistant zone, wherever your building is in earthquake prone zone, we have to refer IS. I'll write it here. We have to refer Indian Standard 13920/2016 is a new code book. Based on that, we are going to do this detailing. Okay, right. So I think most of the things we were able to understand through this lecture. And foundation details we have understood, the column details, the plan we have understood, the footing schedule we have understood, and also we have understood how to read this particular column details also. Again, column details, if you want, I can show it once again. Yeah, now you can get a better picture. Yeah, see, you have a PCC, then this was your D1, this was your D2. Okay, and then you see from here to here, this is D3 or D4, both they are mentioned. Okay, D3 or D4, since you're seeing it from the front side. Actually, back side also there is. In this side we have, but since it's a front, no, that is why they have mentioned D3 and D4, D3 and D4. It's nothing but the offset what you have from the column to the outer of this particular footing. And then next you are going to get the plinth beam, and then you are going to get the column. Now this is your floor to floor height. What is a floor to floor height? From here to here, it is my floor to floor height. From here to here, it is my floor to floor height. And then you are going to get that confining zone. All these are your confining zone. From here to here, it has to be 750 confining. And from the bottom of your beam to this portion, it is 750. Okay. And the remaining is a normal zone. All these things, this is a roof beam. Exactly. See, they mentioned it as a roof beam, isn't it? That is what I told you. Roof beam, and this much portion will be a slab. You're getting my point? See, actually, this is slab. This much is a slab, because slab and beam will be casted monolithically, right? So that is why. And this much, the green one is your beam. Got it? Yeah. Try to see how the slab layout has been given for this particular building. It's an industrial building what we're discussing, and we'll see that. Yeah, so you can see it here, right? The slab layout has been given. So it's written here, layout of roof slab. At what height? It is at a 5-meter level, okay? From the top of your concrete. That means the top of your concrete of a slab should end at 5-meter level, right? So this is what we mean by that. Now let me try to zoom in, and you can see it here. All these are the slab. Like we know these are the grid lines. 1, 2, 3, 4, 5. All these are grid lines. A staircase is coming here, right? And in this way, they are given it here. Now, one thing you need to understand, can you see here? They are mentioned like 1, 2, 5, 6 and all. So since I told you this particular drawing is bit complex, you can see a lot of numbers has been given, isn't it? 1, 2, 5, 6 and all. So this number actually indicates the diameter of the bar. In previous basic course and also in the previous drawing, all the things was written here, isn't it? But here what they have done, here what they have done is that you are given a number and then they have shown a cross section here. You can see a cross section being shown here, right? So in the cross section, they are given it here where they have cut the section. So this particular section they have cut at A. You can see A here and you can see B here, isn't it? Right? So that means this is that A and this is that B. So this particular cross section they have cut it. This particular cross section they have cut it, right? And now you can understand how the reinforcement has been given. It's very simple now. You see it here. So in the bottom bar, they have mentioned it as 1. The top bar, they have mentioned it as 2. And then again, they have mentioned this as 5. And again, they have mentioned this as 6. The same thing, you can see it here. You can see it here 1, 2, 5, and 6. This is what you can see, right? Practically, the same thing they have mentioned it here 1, 2, 5, and 6. Now, one thing you can understand, this 1 and 5, it's shown in the bottom. That means it's a bottom reinforcement for the slab. Whereas 6 and 2, this is shown at the top. That means it's a top reinforcement. Very simple. And now you can see a kind of extra bar given here. You can see from here to here. You can see a small bar given here. See a small bar has come from here, isn't it? It has stopped here up to here. And at what distance it has been stopped? It is 1800 mm is the distance what you can give from the outer face of the column. You are getting my point? So in this way, all these things are given, and based on that, we have to do the execution. Of course, I do understand it's a bit difficult now initially. Delete this. Yeah. Yeah. So again, along with that, you can see it here also. I'll show you one more beam for that matter. Yeah. So again, you can see the same thing here. They've written it here, right? See schedule of reinforcement, like what is 1, what is 1A, what is 2, what is 2A and all. You can see here a lot of things written. No? See here 10A is written, 9A is written, 4A is written, 3A is written. But only the name is written. They're not mentioned the reinforcement here. For the reinforcement, you have to refer schedule of reinforcement. So it's a completely different way of giving our reinforcement. Now, for example, 1. So 1, it is written, you have to make use of a 8 diameter bar at 250 center to center spacing. And for 1A, you have to make use of 8 mm bar at 200 center to center spacing. Now, B in the stance, it's a bottom bar. This both 1 and 1A, you have to provide it in the bottom. Whereas 2 and 2A, right? So it's written T and T. T means stop. So where exactly we need to provide that? So you have to go back here again. 1 and 1A. We'll see where it is mentioned. 1 and 1A. So 1 and 1A. Yeah, you can see here 1A is written here, isn't it? And 1 is written here. 1 and 1A. Then again we had 2, isn't it? So this was 2 and this was 2A. The other way of understanding this drawing is that always remember the one which is shown in the dark color, no, like this particular line. It's a dark in color. Agree with me? So it will be always a bottom reinforcement, the one which is shown in dark color or which is not a dotted line. And you can see the other one. This is a dotted one, isn't it? Agree with me? This is a dotted one. So this will be my top reinforcement. So if you don't understand this, again, if I go look here, 2 is a top reinforcement. How did I identify? Because it is in dotted color. So in order to cross verify that, I'll take you to this schedule and we'll see that. See, if you understand all these things, it's well and enough. You don't have to be, understand the complete drawing. A basic understanding, if you have, like what all those numbers indicating, that is far enough for you to do the execution on the site. Okay. Yeah. So you can see it here. What is written? I told about 2, right? See 2 here. 2 is written. It's a 8 mm bar at 250 center to center spacing. T is written. So T in the sense it's a top reinforcement. So top reinforcement we denote with the dotted line. This is yellow. You can see it's a dotted, and bottom you can see, you know, one was my bottom, isn't it? So it will be dark in color, right? So that is a basic difference what you will have in the structural drawings. Now again, I'll take you to one more. Yeah. So even we can see this also. See here at this particular cross section, it's written section 2, isn't it? Why is that there is a difference here? One beam at the top, other beam is at the top. So whenever we have a level difference and all, no, we try to give it. Maybe the slab which is coming here, maybe the slab is somewhere at this portion, whereas this slab is little down. So in that way, we try to give in this way, right? So you can see one reinforcement is given in the bottom. I mean here, the other is coming here. So whenever we have a level difference in the slab, right? When I say level difference, that means let us say you are taken one slab. Your one slab is coming here. Okay. Let us say it has come here. Come here. Whereas let us say the next slab, whatever you have, no, it is coming somewhere here at the top portion. So this level difference, whatever we have, no, we need to take care of that, right? So that is the reason what will happen. We give such level difference, and you can see the level difference being given here. So this is that level difference what we give. Okay. Yeah. Yeah, you can see the same level difference here also. You can see here also, right? Yeah, see here. So this is one beam here, and this is, so whenever I say level difference, just try to see the this thing. You see, it's written 5.0 meter top of the concrete, whereas here you can see it is 4.625 top of the concrete. So what is the level difference you have? Very simple. If I deduct 5 meter minus 4.625, roughly I'm getting 375. So this 375 mm is the distance what I have from here to here. So usually this happens whenever you give a sunken slab and all. You're getting sunken slab because this much may be your toilet portion. In the toilet portion, we give sunk slab, right? So in that case, this usual difference is going to happen, right? Yeah. So other than that, most of the things I have covered it here. Okay. So the main intention of taking this drawing was just to understand like what exactly this 12, 11, 4, 3 number indicates. Now, I hope you are in a position to understand that. Again, if I want to understand what is the reinforcement for the 4 here, come here, you can see here 8 diameter bar at 250 center to center spacing, T is written. So it's shown in top, no? By default, it has come to the T. Now again, I'll verify the T, whether it is given dotted in the plan or not. So I'll go back to the plan and we'll see the number 4. I'll search for number 4 here. So the number 4 should be somewhere here. So it is 1, 5, 6, 1, 2. Yeah, not able to find number 4 here. Yeah, so you can see here the number 4. This is that number 4, and you can see how is the line shown. It's shown dotted, isn't it? Why is that? Because it's a top reinforcement, right? So that is how you are supposed to understand. So if you understand up to here, it's very simple. I have already got all the concepts. Like I mentioned about the sunken slab, you see here, this is a sunken slab we have. We have a toilet area in this portion. Similarly, I have a toilet area in this portion. So whenever I have a toilet area in this portion, that level difference will come. So that is why that level difference was shown here. You can see that this level difference was shown here. This is that sunken portion, and this is how it looks. Yeah, again, to put it in a better way, you can even see from here. Just concentrate. So with this, we'll understand most of the things. You can see the grid 1 given here. You can see the grid 2 given here, and you can see the grid 3 given here, right? 3 given here. Good. So you can see the same thing given here. That's a one grid. This is the second grid what I have. Third grid is over this, no problem. Now see on the second grid, I have a sunken slab coming here, right? And you can see it here. This is that portion. This grid and this grid represents the same thing. And you see, this is a sunken slab on this side. It's a sunken slab on this side. So you can see this is a sunken slab on this side, and this is a sunken slab on this side. So that is why this is a level difference what I have. The same thing you can see in the plan, right? And after that, beyond this point, it's a normal slab what I have. And beyond this point, it's a normal slab what I have. So beyond this point, it's a normal slab what I have. And beyond this point, it's a normal slab what I have. You're getting my point? So whatever is given in the plan, they've cut a section and they've shown it to us. So that is how we are supposed to understand this drawing. And if you understand this drawing, there's nothing confusion left if I give you any other, because this is one of a complex drawing what I've taken when I'm seeing it for the first time, right? I think most of the things I've covered from here. Okay, again you can see now you have understood why there is a level difference and all those things whenever you get the sunken slab and all. Okay, yeah, great. So I hope up to here your concepts are clear. We have understood about the roof beam layout, roof slab layout. Also the reinforcement details is understood to us. Yeah, one more thing. See here, whatever reinforcement you can see, everything is a cut reinforcement. It's not a crank bar system. Usually in the industrial building and all, right, we don't go with a crank system. Most of the industrial building and all, we don't give this crank system like a bent bar. Huh? When I say crank, we don't give it something like this. Okay. So what we do is, I already explained you what we exactly do. We give the bottom reinforcement. We give the bottom reinforcement. Then we put a distribution reinforcement in this way. Okay. And once the bottom reinforcement and once the distribution reinforcements are done, then we put the cut reinforcement. Now, what is this cut reinforcement? Like from here. Okay. Yeah, from here up to this portion, let us say your cut reinforcement. Okay, it's on the top. Okay, what I'm providing is on the top, on this side. Similarly on this side, if it, on most of the time it will be a two-way slab only. Okay, but depends, but still most of the time it's a two-way slab only, unless, yeah, again this is a cut reinforcement. Okay, this is actually top extra bar what we are given, and then of course you have to give a distribution bar to this. Okay, below this your distribution bar will come. Okay, this distribution bar will be for top reinforcement. For reinforcement you are going to get bottom straight, bottom vertical, top straight, top vertical, right? In this way, you're getting my point. Same thing will come on this side also. So now this will be similar to your crank bar distribution. That's it. Okay, so here crank would have come, it have gone into the bottom, it have gone to the top. So here we are not giving a crank, only we are cutting the bar, right? So that is why you can see here, that is why you can see it here, right? So this is that reinforcement what we are given. You can see the bottom reinforcement here. This is bottom horizontal and this is bottom vertical. I'll do it here. See, this is bottom horizontal, let us say, and this is bottom vertical. Okay, in the same way for the top, yeah, the top, this you can see the dotted. When I say top, it should be dotted, so you can see a dotted here, right? So again this is top horizontal and this is top vertical. Okay, in this way we try to give the reinforcement. And wherever the extra bar and all will come, it is mentioned here in the drawing. You can see the extra bar, right? See this extra bar, from here to here it is 1800 mm. So again from here to here it is 950. This is extra bar. You can see how the extra bar they have shown it here. I'll zoom out, zoom in. See, this is that extra bar. Okay, it's not visible for you, it's over that only. So that is how, of course, if you've taken my construction methodology course and all, you'll have a very good clarity. Okay, since it's advanced course, if you have taken basic, you'll be in a position to understand this. Yeah, I'll be taking you to few of the other structural drawings for a very high-rise building, and we'll try to see that how it has been given. Whatever drawings is possible from my side, I'll be explaining you that, right? Yeah. So now I'm showing you one of the drawing where this particular drawing, what I'm explaining you, is actually a building which is designed for the 4 basement. When they write 4 basement, there is 4 basement, and then comes your ground level. And after the ground, you have a 25 typical floors. That means how it's going to look. So very simple. I'll do it here. Let us consider if this is my entire building. Let me do it in this way. Yeah. If this is my entire building, right? And at one particular area, let us say somewhere here, this is my ground floor. Okay. This is my, yeah, this is my ground floor, right? So below the ground floor, I'll be having 4 basement. So this is, let us, basement number 4. Okay. Then this is basement number 3. Okay. 2. Sorry, I'm going to have to go it other way around. Okay. Let me repeat it once again. This is my basement number 4, 3, 2, 1. This is your ground level. Okay. So ground level, usually maybe whatever buildings are there. Here basement, you can use it for other purpose and all. Okay, especially for the car parking, you're going to use the first 2 basement, and you can use it for other activities. And after this, whatever I have how many floors? I have another 25 floors. So over this I have another 25 floors. Just imagine how it is going to look. 1, 2, 3. So in this way there are almost 25 floors after that, right? So this is how the structural drawing for that is for that particular building is made. So whatever drawing is I'm having, I'll be explaining that. Right now I have a column details. So just see here how it is given. Okay, so they have given the dimensions for the column here, right? Just understand the size. Yeah, we'll start from here. So this is a column dimensions they have given. It's a column schedule what is given. Can you see it here? Column schedule for the tower U, and here they have given a column number and all. Okay, the column number is BC1, BC3, BC5, BC7. B in the stand, it's a basement column 17, basement column 19, and so on. Now what is the size of a column? It is given. It is 230 by 1925. And look at the interesting part. Look at the grade of a concrete. It's a M35 grade of concrete. So far, if you had taken my basic course or maybe even this in advanced course, we were actually using a M20, M25 concrete, right? But since it's a very high-rise building, here even strength is also important for us. So unnecessary, instead of increasing the sizes of the column and all, we will try to increase the size of a unnecessary increasing the steel or the size of a column. It's better to increase the size of a, it's better to increase the grade of a concrete, right? If you increase the grade of a concrete, what will happen? More strength and all is going to come, right? Yeah. And here they have mentioned all these things. Diameter, you have to make use of 8 diameter bar at 150 center to center spacing. Okay, and then here they have mentioned what is the bars you're supposed to use. Just imagine here you have to provide a 16 diameter bar 12 numbers, you have to provide a 12 diameters bar 28 numbers, and you have to provide a 10 diameters bar of 56 number. So just imagine what is the amount of reinforcement coming in this particular column. Okay, right. In the same way, usually it is not a kind of a column, it's a shear wall, because if you try to understand this, see what is the dimension given? It's 230. So 230 will be hardly this much, and 1925 will be something like this. So this is a kind of a shear wall itself, right? And here you are supposed to provide all this reinforcement: 16 diameter, 12 bar, 12 diameter, 28 bar, and 10 diameter, 56 bar. Got it? So in this way you are supposed to understand. In the same way, if I go to the, this is right now what I did is 25th floor. Now here you see the next is 23rd floor. We don't have a 24th floor here, right? Next you see here we have 20 floor, then we have 17. Usually in the high rise building, what we try to give, every alternate floor we try to give same reinforcement details. Here you see after 25 we have come to 23, like 25, 23, then your 21. All this will be same reinforcement or same size of a column and all. Then this is my odd one. When it comes to the even part, maybe in the next drawing, let me check if there is even part. So in the even part, what will happen? You are going to get another set of drawing where your floor will be even in number. Like right now we have here ground floor. After that we have something called as service floor. Then it is a sixth floor. You can see 8, 10, 15 in this way. All these things are given, right? Yeah. Again, you can check the size here, 230 by 1925. Again, you see the grade of concrete. Here they have gone for M45 grade of concrete, right? And also see the reinforcement how it has been given: 20 diameter 8 bar, 16 diameter 36 bar, 12 diameter 52 bar. So in this way the entire uh, column details has been given, and based on that the execution is going to happen on the site. And then obviously these are the things which we know about the column reinforcement. They have given it, how your column reinforcement, how the typical detail of a column should look. Those things they have given it here. Okay, yeah. So after this I'll take you to one more drawing. Yeah, so you can see it here. Now you see here, this is another drawing for the same, I mean it's the same building. We have a ground floor here, then after that we have a first floor. You see now this time it is third floor, then fifth, then we have sixth, then we have 8th, 10th, 11th, 13th. So in this way whatever floor was not there in the previous drawing, they've added it here. And similarly you can see all these things has been given here. Okay, the size of the column, what grade of concrete you are supposed to use, and what are the different diameters of bar you are supposed to use it here. So in this way again the drawing is made up. Again they have given here column schedule. This is for tower number 5, because when a high rise building we have a many towers, right? It's not that only one building we are going to do that. Like if for example, if this is my plan, okay, if this is my area, then we'll be doing a lot of building. Let us say this is my tower 1, tower A. I'm going to put tower B somewhere here. This will be my tower C. and then this will be tower D, then it is a tower E, something like this, right? So when it's a high-rise building, you try to create a kind of a society there. So in this way, you can see the column schedule for the tower 5, tower 6. In this way, all these things will be given, and also the column name is also given, CC1, CC2. So all these are the names given by the structural engineers based on their requirement and based on the detailing they have given. So again, if I try to maximize this, it's the same thing. Just wanted to show you how the drawing is going to look and how the sizes of the columns are given. So you can see all the reinforcements and all, right? Yeah. Again, this is a typical detail what you get in the 23rd floor where you have to do the lapping and all. Okay, those things they have mentioned it in the typical junction drawing. Yeah. So other than that, I'll show you one more drawing. Yeah, I mean, it's the same drawing only. Here again, they have given a different way of detailing it here. So here, how the columns have been given. So here, it is a 600 by 800 column. You have to provide a 16 diameter, 20 number of bar, and see how the lateral ties has been given. This is your master ring, the yellow color. Then comes your next ring. It is here. Then this is my next ring, which comes here. Then our hook is going to come, and then one more ring is going to come. Right? So again, you're supposed to provide a 10 diameter bar at 75 center to center spacing. So in this way, all this detailing will be given. It's written here, column PC 27, 57, 58, 59. All these columns which belong to this number, you have to follow this particular detailing. In the same way, if I go to one more column, you see here, this column is column PC 39. Okay, and see how the reinforcement has been given. See, you have to provide a 20 diameter 10 bar here, and also you have to provide a 20 diameter 10 bar here. Then you have to provide a 16 diameter 6 bar here, then a 16 diameter 6 bar here, then another 12 diameter 2 bar extra you're going to provide here, right? And then along with that, this is how the lateral test has been given. This is your master ring, the middle one, you can see it here. It's this is that master ring, and then this ring you can see it here. Okay, then again you have this ring you can see it here, and then all these are the another rings. You can see this is one link, that link you can see it here. Then this is one stirrup, two leg stirrup, you have one two leg stirrup, another two leg stirrup, so another two leg stirrup, another two leg stirrup, another two leg stirrup, what you have it here. Okay, similarly you can see one two leg stirrup, it's here, next is here, next is here, you have it here, right? Then this is one link, you have one link here, and you can see it here. This entire thing is even again, this thing, your this particular mastering what you have to provide that at 8 diameter bar at 150 center to center spacing. This is also at the same, whereas this lateral test what you have, no, this you have to place at 75 center to center spacing. So in this way, all the details will be given. We had not seen a drawing similar to this. Again, you can see it here also. See how the detailing has been given. Again, this becomes your master ring, and all these are the other internal links what we have. Okay, and again the size of the column, it is 600 and this is 1600 and all this other reinforcement you have to provide a 25 diameter 3 bar. So you can see 1, 2 and 3. This is 25 diameter 3 bar, and 1, 2, 3. This is also 25 diameter 3 bar. Okay, now how do you identify that? See, it's there, they've given a small this thing, isn't it, a dotted line here. Can you observe that dotted line path? So this is a 25 diameter 3 bar. Similarly, you can see it here, a dotted portion. So again, this is a 25 diameter 3 bar. Similarly, see it here, this much portion what you can see, no? So it's a 25 diameter 3 bar. Similarly, this dotted portion you can see, right? So it's a 25 diameter 3 bar. Now whatever is left, so whatever is left, which is the left portion, this much is the left portion. See, they have done something like this. This portion will be your remaining diameter, that is it's written here. You have to provide a 20 diameter 12 number of bars. So if you count 1, 2, 3, 4, 5, 6, 6, 6, 12, yeah, 1, 3, 4, 5, 5, 5, 10, this is 11 and this is 12. So 20 diameter 12 bar you're supposed to provide in this portion. You're getting my point? So in this way, all the reinforcements will be shown, and based on that the execution is going to happen. Again, these are your lateral ties, right? So most of the things I've covered it here. If you understand it for one, rest things are very simple. This is a very simple detailing. I've taken most complicated drawings also here, right? Yeah, here also it's very simple. It's a 300 mm by 600 mm. So to provide a 16 diameter 3 bar here, 16 diameter 3 bar here, and a 12 diameter 6 bar 1, 2, 3, 4, 5, 6. And these are your lateral ties what you're supposed to provide. Master ring, then this ring and a link. So this link will be here, right? Yeah. Again, all those things will be mentioned. Which column is that? What grade of concrete you're supposed to use there? Which column is that? All these columns like PC 23, 24, 25, 29. For that, you have to refer this particular detailing, and based on it, the execution will be done, right? Yeah. So when a high-rise building and all comes, you only the column detailing will be more typical, and also the beam detailing. Slab always remains the same. There won't too much complication in the slab. Right now, I don't have a slab drawing with me. Foundation, most of the time we go with the raft foundation only, right? So in the raft foundation, you get a bottom mesh, you get a top mesh, and that is how you try to put. So the typical drawing will be usually the column details and also the beam details. So these are the typical drawings what we try to get. Yeah. So I think most of the things I have explained you here. Other than that, yeah. So this drawing is also explained. Yeah. 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 So I hope up to here your concepts are clear. You at least got an idea like how a high-rise building drawings will look, how we need to understand all. The rest all things will remains the same. How you do the typical detailing and all that remains the same, right? We'll try to take one small renovation building, okay, and we'll try to see how the drawings has been worked out for that. Let me give you a small idea regarding what exactly we are going to do. Okay. See, this is one of existing building plan. There's one building, there's one house which is here. Okay. We wanted to do an extension here with the help of a steel structure. So that is why all these things has been given. So this is a compound actually what we have. Okay. This entire thing, what you can see, this entire thing, what we can see, it's a compound what we have, right? And there's a house which is already built here. So our intention is to look into the foundation details. You can see 1, 2, 3, 4, 5, 6, 7. Almost 7 foundations have been given, and over that we have put a anchor bolt, and then the steel structure has been erected. I'll show you the picture also for that, so that you get a better idea what exactly we are going to learn. See, so this is a existing house. If I put it in this way, yeah. Yeah, so this is the existing house here. Okay, so you can see a kind of a steel structure being made here. We wanted to put up this. Okay, so how this has been done, we have a foundation here. We have put a foundation here, and even on this side the foundation has been put up, right? And then this columns has been kept here. These are the steel columns what we have, and then we have done the cladding work, the sheeting works and all, and then the purlins, the rafters has been arranged here, right? So this is the overall thing what we are going to look into the drawing now. So I'll take you to the drawing now first. So I hope this is an existing building and these things we are supposed to understand, right? Yeah. So first you see here what is given. Again, the foundations are given. This is F1 footing, F1 footing. Everywhere it is F1, F1. Here also it is F1. Everyone there is F1 fitting. Okay. And what is the size? You can get the size from here. Otherwise, the other option is that come here. It is given here. Footing schedule is equal to 1200 mm by 1200 mm. And what is the depth of the footing? It is 250 mm. Okay. And then the reinforcement has been given along the shorter span and along the longer span. You have to make use of a 12 diameter bar at 200 center to center spacing. So in this way, whatever footings we have, we are going to do the all this arrangement, the size and this particular reinforcement we are going to arrange. Okay. So after that, what will happen? You have a column. So here it is called as pedestal. So you can see here, this is one pedestal, the second pedestal, then you have another pedestal here. So in this way, the pedestals have been given. So they are given a name to that. Okay, C1, C1, C1. Here it is mentioned as C2. Again, it is C1, C1, and C1. Now again, what will happen? We will go to the drawing. it is mentioned here. C1 and C2 column. The size is 400 by 400. You have to make use of M30 grade of concrete and M30 grade of concrete. And reinforcement will be a 12 diameter 4 bar and a 12 diameter 4 bar. Coming to the stirrup, you have to make use of a 8 mm stirrup at 150 center to center. Here also 8 mm at 150 center to center spacing. So you can see it here. This is a one stirrup at 150 center to center spacing. Okay, so this is in diamond shape, something like this. Okay, here it is kept straight, here it is kept in this way, right? I hope this much things are clear. And here you get the details like how it has to be done and all. Okay, see, you're going to put a PCC, and this is a footing size which is 1200 by 1200. This is a footing reinforcement. So your depth of the foundation will be 250 mm. Depth of your foundation is 250 mm, and from there to the height, this much height, it will be 500 mm. You have to provide a column, that is a pedestal you are going to provide. Okay, and after the pedestal, you can see this. These are called as anchor bolts. Okay, since it's a steel structure, right? We have to erect this column here, that ISMB channels and all. Okay, so that is why we have to do the anchoring of the steel bolts. So here it is mentioned that it is an anchor bolt which is a 20 mm in diameter anchor bolt, and this is a column what we have, right? So in this way all the arrangements has been given, and according to that the execution will be done on the site. Now coming to this part about the column part. So it is mentioned here like we have P1, P2, P3 and P4, right? Again the size is given here, size is 490 by 490, which grade of concrete and what is the reinforcement you are supposed to provide. So in this way each and everything we know the basic, how these things has to be understood. So the important part is that about the pedestal column, about the steel details. So now coming to the steel, so this is the column what we have, isn't it? Over that what will happen, you are going to provide the base plate. So you can see it here. Yeah, so you can see a 16 mm thick base plate you are going to provide. So I'll actually show you an image, but exactly I'm trying to explain you so that you get an idea. Okay, so whenever we do the steel structure erections and all, see we are going to do the concreting of this column, right? And along with the concreting of this column, we are going to insert this bolt. Now how many bolts you are supposed to insert in this column, it will be mentioned in the drawing. For example, if I go see here how many bolts you can see, 1, 2, 3 and 4. There are 4 bolts, isn't it? Right? So the same thing you can see it here practically. Right, so there are 4 bolts, isn't it? The same thing you can see it in the drawing. The 4 bolts have been given, right? Yeah. In the same way, if I show you one more drawing here, see here, this is another different column. Here so many bolts have been given, and what is the distance between these 2 bolts? Okay, what is the size of this particular base plate? Each and everything will be mentioned in the structural drawing. You can see that. See the distance between these 2 bolts, it has to be like 100 mm. From this center line to this, from this center line to here it is 50 mm. From this center line to here it is 50 mm. So you can say 100 mm given here. So in this way all the things are going to be mentioned in the drawing. Similarly, what should be the base plate size and all those things. Okay, again from this center to the outer of the base plate, from this center to the outer of the base plate, how much it has to be? It has to be 100 mm. Okay, from this center to the outer of the base plate, it has to be 100 mm, and from this center to this center it has to be 100 mm. From here to here it has to be 50 mm. From here to here it has to be 50 mm. Getting my point? Everything will be mentioned, and based on that the steel structure erection or the base plate setting we are going to do. So this is one of important work that you're supposed to do if you're working as a site engineer, especially in the industrial structure. You should be very careful here, because you cannot make any mistakes here, because once you're going to place the bolt, the columns are going to come and they are going to get inside this bolt. So there should not be any deviation of this anchor bolts here, right? Yeah. So again, base plate thickness will be given 16 mm thick base plate. This you are going to get if you give an order to any of the company, they'll manufacture all these things. Okay, it's a 16 mm thick base plate they are going to send. Then the 4 bolts they are going to send you. All those things they are going to send you. So in this way, you can see a lot of for different columns and different sizes, all these details has been worked out. Here also you can see the details has been worked out. Here also the details has been worked out, right? So in this way, each and everything, the details has been worked out. Yeah. So that is what this drawing is all about. So in this way, you're supposed to do that. So, and finally, once that is done, no, you can say this steel columns here. These are your steel columns. Now it is gone. Like when I took the photo, all these things, they have put a tiles and all. But actually the anchor bolt, you could have seen the anchor bolt here. Okay. Anyway, I'll explain. You could have seen 4 anchor bolts here. 1, 2, and 3, and 4th, the other one on this side. Okay. And this particular column, what you have, it will have holes. It will have holes in that, so that this column will directly sit inside this particular bolt. Okay. It's going to sit inside this bolt. So that is why when I explain about the drawing, they have shown it all these things. You can see it here. This is a bolt what I have. Okay. And this is a column. You can see the column is written. This column will come and sit inside this bolt, and then you're going to tighten the bolt again, right? So that is how you try to do it. That is how you try to do it. So again, so you can see here 1, 2, 3, 4 columns they have done, and after that it has been connected with the help of a rafter, and then all these other, here you can see the purlins has been given, and then the sheeting work will be done. So this particular thing is called as gutter. From here, if any rainwater falls, like I'll show you, see, this is called as gutter. Okay. If any rainwater falls, the rainwater will come, it will come through this pipe, then it's going to fall on this particular roof. And here, this is a gutter what we have. It will flow into this gutter, and from here we have this drain pipe, and through the drain pipe we are going to take it to the ground. So in this way, all these connections will be done, and that is how the execution is done. I mean, for the first time, if you're looking, it's a bit difficult, but it's very simple. Up to here, normal RCC we do. Then this is a steel structure. All these things you are going to manufacture in the factory, and then you are going to bring it, and with the help of the crane, you are going to erect it. All these things, the erection will be done with the help of a crane and all. Okay, this is how you are supposed to do that. And all these are the rafters, the purlins and all. Again, what should be the size of this? What should be the spacing of this? All these things you are going to get a different drawing, and based on that, they are going to do the erection. Usually, the fabrication people will get a drawing for this, and they are going to design, or they are going to make this particular steel columns and all according to that sizes. So I don't have a drawing for that. Whatever drawing I have was only up to the bolt system. Okay, all these things will take it, and we are going to erect it here, and then we are going to tighten it. We'll tight all these nut bolts and all. You can see here how the connections has been done. So in this way, we are supposed to do all these things. Okay, here all the bolt connections has been done. Again, you have to design all these bolts and all. You need to check what is of course, there is very little live load coming here. Only the dead load is going to come, and that is the self weight of the material. For that particular load, what should be your connections here? Based on that, we are going to do the designing. Again, we should be good in steel design. In this, we have to do the connection designs and all, right? And that is how all these things are coming. If I go back, you can see here, it's written 20 diameter bar. So 20 diameter anchor bolt, you get 25 diameter, you get 16 diameter also. So why the 20 diameter has been taken here? Because maybe for the load which is coming, this 20 diameter is sufficient enough to take care of the load. So that is why we are given a 20 diameter. So these are called as connection designs. So if I go back here, so all these are the connections what we are given. So this is a connection design. 4 bolts we have given it here. 4 bolts we have given it here, right? So in this way, we try to design all these things, and this is how the drawing is prepared, right? Yeah. So I hope at least now you have got a better idea about how this particular erections and all has been done. And I hope up to here your concepts are clear. Most of the things I have covered it from the drawing. There is nothing much. This is a drawing what I had. So that is why I thought to explain it here. Yeah, along other than that, those things they have mentioned it here. Okay, the anchor bolt details and all, which I already shown you. Yeah, you can see one more thing. Yeah, very good. See how many quantities of such bolt has come. 28 quantity of bolt has come. What is the diameter of a bolt? It is a 16 diameter bolt. What is the length of this bolt? Okay, yeah, this is very interesting. See, this is the length of the bolt from here. From here to here, the length of the bolt is 700 mm, right? It is 700 mm. You can see the same thing, 700. Next, A, it is 150 mm. B, C, D. Okay, this is a different dimensions what they are given. Okay, A, B, C. And then once you do that, see, this is your footing level. Okay, This is your, this is your column level. If I bring it here, yeah, this is my pedestal level. Up to this level, I'm going to do the concreting of my column or a pedestal. And after that, this is a 50 mm grouting. What we do, you can see it here. It's written 2 inch or 2. Yeah, it's a 2 mm grouting. What we are supposed to do. No, it's a 2 inch. Okay, not mm. This mm should go. It's a 2 inch. That comes out to be 50 mm. So this 50 mm almost grouting. Grouting in the sense you get grouting powder. You try to put a grouting here so that it will sit properly over there, and you get a horizontal surface here. Why this grouting has to be done? If you don't do the grouting, this surface won't be uniform. When you do the grouting and all, what will happen? You get a uniform surface, so that what will happen? These anchor bolts are going to sit over that properly, right? So in this way, again, it's written double nut is written, lock nut and double nut. You're going to tighten this, and this is how the columns are going to be seated on this particular pedestal, right? So those drawing, they have mentioned it here, and most of the things we have understood. Yeah. So we'll see you back in the next lecture. Thank you.